Good morning, sir.
Good morning.
Morning.
Sir?
I think sir joined the audio as it's can't hear us.
Oh, all right.
Good morning, all. How are you?
Good morning.
How are you doing today?
All right, now.
How are the preparations going?
Sir, I can't answer that.
Lord Jesus, forgive Peter Gilwald, not Jesus. Forgive Kimani, forgive Kenisha, forgive Ronnie, forgive the whole of them. Alright, let us see what we can do. What I give the resident time to read code. Okay, I think I need to do, and I'm not comfortable with. I'm not comfortable with this. So I'm doing one more of this. But, oh Lord Jesus. Did I do the natural logarithm differentiation with you last week? The ln x
Sorry,
function?
Pete?
Did I do the ln x function with you last week?
Yes, sir. You started it.
I started the ln
Yes, sir. You
function.
did it.
Okay, great. I'm worried that I want to stay far from differentiation today because I'm worried that I touch it and I use a whole 4 hours for it. I have to move. I'm still in unit 1 and I must complete unit 1 to jump into 2. So I'm going to do this past paper and I'm going to do this past question. And at some point in time, okay, so I did the ln x function. Okay, so I'm going to do those 2 Maclarens. Okay, so I'm going to so I'm going to do, let me give you this as a warm up. I give this back to you as a warm up. Share screen. Alright, I'm giving you this question as a warm up. Find the derivative of the function f at the given point if f of x is equal to x cubed ln x. What method do we use to work this question, please? Suppose to find the derivative. So you're differentiating. Which of the rules you use for this question? Talk to me, please,
So you're
somebody.
using the chain rule
No,
and then. Sir, am I wrong?
you know, it's supposed to be the product rule. Remember, x cubed is being multiplied by ln x.
Also, you use a product rule, then
It's
the
the
chain
product
rule.
rule.
Come on, say.
No, it's just a product rule you're using. Once it is that you see a multiplication, x cubed is being multiplied by ln x. It's a product rule. First times the differential of the second plus the second times the differential of the first. I'm going to give it 5 minutes. This is just a warm up. I do 5 minutes. I take another 5 minutes and do the solution. Then I move into Maclaren's. Move back into Maclaren's. All right. So take 5 minutes, please. At 18 hours, I'll be back with you.
Morning, all. Morning.
Okay, so good morning, Everton. Good morning, Kamar. Candice, you weren't here earlier. Good morning. And good morning, Shanice. Yes. And that's about it for all the students in my class this morning. Candice, Everton, Kamar, Kenisha, Kimani, Peter Gay, and Shanice.
So why? So what happened to the rest of the students that are supposed to be in your class?
I
How
have
many
no
people?
clue. Oh my goodness. You tell me. I have no
Them
clue.
still up on holiday.
Well, make them stay now because guess what?
Sir, I think you did a market, that's why.
No man,
Sorry.
no. Remember, say every other week we go marketing.
Oh,
So I went there last week. So come next week now, I'm supposed to be going. And so by the sometime before the end of the class, we need to have a conversation about our mid-semester exam.
sir, we're
Yes, please.
not final.
I sent it. I don't know the timetable. I have not seen the final draft rather. Somebody called
On
me
the
again.
10th of September, the exam. September the 10th, yeah.
Hold
Right.
on. So we now have another test on the 10th.
Yeah, well, I've clashed with telecommunication, but it email miss.
Miss
What's your
Campbell?
name? That lady. Yeah.
Miss Campbell, I did email her too, but they never change it.
I guess not gonna make we know what we're gonna go forward.
And I thought about the exam draft.
Yeah.
Yeah, the
Okay.
final draft. You know.
Who's
Oh.
this? Who's this speaking?
Sir,
People-
Sean, sir,
people-
if I want to be in their class, sir, I reach before you, know, sir.
People dead. Melt him.
You know, Everton, conveniently, I called everybody's been away from this because last week, them never showed to my class and me have them up. No telephone call, no message in the group to say, sir, I have a difficulty or nothing. Them don't turn up, period.
Hey, sir, you
last
can't
week.
say that to the sir. Come and tell the family of the week.
Tell who another week, me not hear nothing, me not never say nothing.
Sir, so you never reply to me. And you
I say
put the
what?
walking emoji.
Oh yeah, so when I walk away, it means that you're supposed to find some time and come. You never get
But-
that message.
They're the easy to ever tell sir.
Yo,
The boss say, yo, wow, come in for work on the server there. But tell sir, you know. Sir, walk away from me.
No. So that means saying to tell them, say, get up and I can't give you only this because I have to go spend it now 1 hour in the class, right? But
boss, which for your work?
I work at FSC. If you know Travis are the same place that Travis work.
Oh,
Mhm.
okay.
Travis
So,
cool.
working at IT.
Yeah, man. Una the real money man, them that you know, sir.
Yeah, the one.
Yeah, well, guess what? When them pass my exam, we can decide, we can plan a trip to Florida for lunch.
My God.
Oh,
Sir, me no,
Jesus.
sir, me no want to go to Florida, sir. I be
Yes, sir. No,
yeah,
we can't
Florida.
go further. That's
Yo,
a
yeah, me
COVID,
and Sana, man.
that's
We
just, sir.
want to go up on off the coast of Trinidad on one yacht.
Can't go
Beat some
Florida, sir.
juice and go
COVID.
easy.
It's crazy.
Well, guess what
Yes,
now? Based on how me hear the things in my run now, that the man, the plan say, yeah, if we get juke before you can fly in again plane. So, we could have stayed at Jamaica, you know, we have only a nice place out here, man.
Yeah, no
Sir,
place in Jamaica, sir. We
Sir,
can't go.
sir,
Enjoy
as
it,
me
sir.
say, sir, if you are going to tell me, say, right?
Eh,
Is either you live or dead.
mhm.
See, it don't matter, you know, Ray. Sir, may I tell you, no, man. I'm okay. I'm fine. I'll stay where I am because
Mhm.
it's either it go good or it go horribly wrong, you know, sir.
Mhm.
Because once it in your body, you know, sir,
Mhm.
the COVID vaccine, you know, sir, there's no if and but or maybe, you know.
Yeah, you can't get it out. You can't get
You
it out.
can't
again.
get it out, and if your body can't cope or dead, you got dead. You can't give me
Absolutely.
you can't tell me say yo is either me live or dead and me nah no choice, me have to take it.
Yeah,
That's
and
crap.
it's something that I've had. I had a long conversation with my wife about it yesterday morning because I was strolling through social media and I saw we're not only in social media now, the police officer who, his team members are saying that boy, when they have training session, when everybody are run from training, him a run towards training, them say the youth is the fittest of the fittest. You not have no complications, no nothing, but the JCF forced him. This is as is reported because I know I'm being recorded.
Mhm.
So as
Forced
is
him.
reported, or allegedly, let me use the correct terms. And they said that boy, what happened to him is that he's been on a tactical training session, and they forced him to take the vaccine. Forced him, and he went ahead and he took the vaccine. And a couple of hours after him take the vaccine, him said to him close IG them said, "Why, say from me take the vaccine, I don't feel good." 3 days later, he's very dead, dead, dead. Right?
And you know why they're forcing it on people? Because the
Mhm.
way how they structured the vaccine and all of this, nothing can happen to no one
Because
after.
it's for emergency uses only, and they put it in such a way, as the correction said, to take all liabilities away from them. No, here my concern, and I'm not here promulgating for you students not to take the vaccine. I've never discouraged anyone from taking the vaccine. I know my position, and I have not yet been vaccinated. Put it that way.
They did across the road from my yard. I mean, sit
But
down
I'm
on my yard and watch if people drive go over there. Me not
I'm
going
Watch the
nowhere.
crowd.
Watch a crowd, man, and laugh off of them.
But I'm going to tell you, I'm not going to be first in line
Go wrong, yeah.
to take this vaccine. I'm not against vaccines. None of us in Jamaica is against vaccine because we never have a choice. From a barn, we get our BGC joke, right?
Yeah.
BCG joke, and we have this. We can't say we're against vaccine in this
Polo and all.
poliomyelitis and them something there. We can't say we can't say we're against it. No, but when I read, and I mean I don't want to bring off my ideologies to you guys, but based on my readings, every time I see something come out and I read, it gives me chills. The final thing I'll say on this is based on what I'm hearing, I have a joke in my family. I said to them that this semester is going to be my last teaching at Excelsior, because based on how I hear, the Ministry of Education is coming to say that teachers who are not vaccinated will not be preferentially treated as for their counterparts that are fully vaccinated. And
That's
any day the ministry says, if I'm not vaccinated, I no longer have a job, I've already prepared my family that I'm going to come home and sit down. I'm prepared to do that, guys. And I'm serious. I mean, if Fillmore called me now and said, Mr. Shand, the ministry sent me this letter for you, and if not, sir, and if Fillmore says, Mr. Shand, please, let's go get vaccinated because you're the head of the department and you're doing this and you're doing that and that, I'm going to say to Fillmore, find a replacement. Because let me tell you where I'm going. So many people have that, and yes, I agree. Many others have taken it and have lived so far. But my thing is, what if something happens to me? I normally bring in $2 every month to take care of my family. Will the government give me $2 give my family $2 every month so that they can live? No.
I'm not gonna do that.
No. So, as I said before, I went to my ophthalmologist recently, and I don't know if it is a tactic because they're saying that persons who are vaccinated actually shed some of the chemicals in the vaccine and it gets into your system. So I don't know if that was his tactics to find out if I'm vaccinated, but he asked me, and indirectly, and if you know me well, Romain, if you ever ask me a question,
ask him straight.
Just ask me straight. Not go around the mother and bush. No, we are big man together. You can come and say, boy, Mr. Shami, can I ask you a question? Yes. I go straight to the point. Nobody going at the bush. So he was going around the bush and I said, you know what, crap, that I'm not that live. And I went and I answered him straight. I said, no, I have not taken it. Right? I'm not going to be first in line. And then he says to me, okay, guess what? If you put on your mask and you sanitize, you will be fine. And based on his response, it suggests to me that I'm a smart guy. It suggests to me that he has not taken it. And I'm saying to you, The other day I came out of the car. The other day I was in the car and was coming out. And I looked at my hands, and my hands were
Old
very
people on. Dry and
ashy.
crack up, crack up.
Jesus, Father. You know what I had to do? I had no lotion in the car. I had to take some more, the same alcohol, and wet up my hand. And I remember a very good friend of mine says to me, Sean, yeah, worry about your hand, I get that. Don't worry about it. There are thousands of products on the market that can carry back your hand to where it was. Don't worry about it.
A matter of fact, now them have sanitizer with moisturizer in there.
So I'm saying to you, my students, please, but the other day something came into my spirit. I'm not one of those who believe in the double mask, but the other day I was going on the road and something got into my spirit to put on a fabric mask and then put on a disposable mask over it. So I ended up wearing 2 masks. And for the last couple of days I've been on the road, I have been wearing these double masks. But I'm going to say, whatever works for you, COVID still a keep. Me I drive and say people I walk without mask on their face, and it is irresponsible. I beg you, my students. You remember, so we have on the north coast, we go sit down and eat food, yeah? And put on beach clothes, and those who have the dad bod can show them big belly and them something there. But guess what? We need to live. Put your mask on, please. I beg of you. But anyhow, I'm giving thanks that you guys are here, near and far. Oh, and I surmise that 2 of Uno are. It wasn't said to me directly, but I surmise that 2 of Uno in the class now are far into another country. I'm gonna ask you.
Yeah, man. Me know who winner, sir.
Yeah, but guess what?
No,
Yeah, man. Chances are, those persons would have been vaccinated. If not, I don't know. It's neither here nor there to me. I don't look at people differently if you're vaccinated or not vaccinated. Whether or not the pair of you who are overseas now are vaccinated, wear on a mask. Do not let your guards down, because even the vaccinated are contracting. I saw this guy on TikTok who he was frustrated. He says, I have been fully vaccinated and this is the second time he's contracting COVID. It's the second time. And he was so frustrated. And sometimes I have to be very careful because I get offended when I watch these TikTok videos and then have the whole heap of indecent, expletives inside there. So I have to be skimming and reading. And sometimes you're talking some things that I want to hear, but it is so loaded with the expletives. But whether or not you're vaccinated, please to put your mask on. Please to just be careful, be safe. How many of you were able to complete this question? The derivative of the function f, and it says at a given point. I will work out at the given point with you afterwards, because at the given point is really not difficult. But how many of you were able to apply the product rule and get an answer for this? Let me hear you. Anybody?
All right, over this, sir. So run through it one time, yeah, sir.
All right, no problem. Before I run through, just give me, go ahead, hon.
Sorry, no,
I got x squared plus 3x squared ln x.
All right, x squared plus 3x squared, x squared plus 3x squared ln x. X squared plus 3x. Okay, all right, fine, no problem. Anybody else? All right, okay, so x squared plus 3x squared plus. Okay, very good. X squared plus 3x squared ln x. All right, very good, Kimmy. All right, so let's go. Let's go. So it's a product rule.
Sir, no about the foolishness, sir.
With what?
You better put up that pad there and write that something there, sir. Because I understand it better when you write it out, sir. I'll show you step by step instead of this.
No, I may have a challenge. I may have a challenge with that.
Sir, why you not charge a tablet, sir, and stop the foolishness? I'm pure foolishness. You keep up a Saturday morning time, sir. Why you not charge a tablet, sir?
Because when I'm a track and field fanatic, so this is really my time of the year.
Jesus.
So
yeah, watch now.
I'm glued to the television. Like this morning, I went to bed like 3 o'clock. You know what I'm doing? Watching diving. Can you believe it? Diving. So I'm up with the tablet with me and checking my stats as I go along. And the other day, recently I grabbed the tablet and I said, sure, the tablet won't charge. And me never want come from in front of the television, man. So me leave the tablet. Tablet is right on the settee side right about now, still uncharged.
You need to get one of those wireless mats. And you can have two of them in the house and you just drop the tablet on it and left it.
You know,
And it charges the tablet.
it's a thought.
Invest in your way forward to make money, sir. Invest in yourself.
I'm to tell you, especially if me forgo resign, I forgo
Sir, right now, sir, right now in my mindset, you know, sir. Me I work from home, you know. And if them say to me, say, yo, me have to vaccinate, me say, oh, wait, you know, man, me can work from, and if them me can work from home, and if them say, oops, but just left this, me a certified mechanic, me go work on car. Run on away, man, if I don't go on about business.
And guess what? And you have all people can talk about it, and you don't have to say nothing more, right? But you know what I'm talking about, Everton. When I say you have all people can,
yeah, man.
Trust me. So you know, the first. Sorry, I'm just trying to do something here for you.
You're saying the first.
Right, I'm just trying to write it.
Okay.
And that's why I said this back thing. I'm trying to put it here so that when I resend the document, you come on, look at this. You can have all of this in front of you here. Okay. Oh no, Marcus wrote it to ND.
The first. The first multiplied.
Oh, sorry. I should also say to you guys, you know, be on the lookout, because I sense it in my spirit that it's gonna happen sooner than later. And I'm hearing little things happening in Jamaica. Even the pronouncement. Well, I heard a pronouncement from the tourism minister, Ed Bartlett, about 2-3 Thursdays ago, when they had some expo at the Pegasus Hotel. He was being interviewed by Emily Sheets, and his take was, if it was left up to him, persons who are not vaccinated will not have a job. And I was like, oh, I saw them things are going. And then shortly after, I hear the Ministry of Education with this lovely advertisement on radio. And then the pronouncement, you know, by the minister, prime minister, to say XYZ. So I say all of this to say that, you know, they are dropping some hints. Now, if you go back to St. Vincent and the Grenadines, there was a near, call it assassination, so to speak, of their prime minister, Dr. Ralph Gonzalez, because
them burst him with a stone.
Not burst, boss. Man, because the amount of blood released upon him clothes,
yeah,
burst head, right? So and last night I saw where the country is pretty much under siege. My words, not theirs, because they are burning down places. Why? Because the government is now mandating the vaccine on the populace in St. Vincent and the Grenadines.
Yeah, man, I'm off a boss him.
No,
but
so
sir,
Angela
it's going to be mandatory, no, sir.
Tufton was considering it. Yeah, man, I saw that article.
Yeah, and in the Gleaner, saying that Tufton is trying to make the vaccine mandatory, and even my friend in New York saying no, it's a case whereby even to go to the corner shop you have to be vaccinated. And I'm like, whoa, because I remember when I was much younger and I was watching TV, and it was just love TV. I was really young, and when I was watching TV, it shows like if you don't have the 666 on your forehead, you cannot go anywhere, you cannot do anything. And I'm like, I think it's different now in a case whereby if you don't get the vaccine, you cannot do anything, because it's been worldwide right now where they're trying to make the vaccine mandatory. And I'm like, when they said the vaccine is going to become mandatory, I'm like, okay, then it's going to be a case whereby if you don't have it, you can't go shop, you can't eat, you can't feed the family, you can't do nothing.
And that's why Peter.
It is planned. I think it's planned, sir. It is planned.
It is planned. And it is a pandemic. And you know the truth of the matter is that's why I said to you in class just now that I am not ready to take the vaccine just yet, and I'm using the operative yet because I have to live. And if they're going to prevent me from the basic amenities of life, to go to the supermarket, to go to the gas station, you know, I may not have a choice. But for now that I have a choice, I'm going to be exercising that choice, right?
But sir, look at this, sir. They know exactly what they're doing because they know that people people like to feel restricted. If they say to you, okay, get vaccinated, you can go outside, they know that most persons are not going to get vaccinated and it's going to go up again. So when it's going up, they're like, try to implement and say, okay, it's mandatory. And I'm like, with the Prime Minister, I'm saying, you are doing something that is working, and yet you are willing to stop what you're doing, do something different, and the plan that you implement is working. Why are you going to change it now when it's working? And you know for a fact that it's going to go up again. So they know exactly what they're doing. They know it's going to go up, and when it goes up like it's going up now, they're going to implement and force the vaccine on people. So they know exactly what they're doing. Everything is all planned out.
And Peter again. Let's wait till Dream Weekend done.
Yeah.
Let's wait till Dream Weekend done, sir.
You're going to have a spike again. And let me tell you the thing.
Remember, I'm going to tell you.
It's spike is
the Dream Weekend done.
But you have another spike to come after Dream. Put it this way, and this is going to be my final.
Oh, wait, Sansa keep to the twin, sir.
You see
Sansa keep our Sugarman speech today.
Rockstone. Let me tell you the challenge. Let me tell you the challenge I have.
More a lot down again. I can't bother.
We put it this way. If you have a cut on your hand, on your body, and you have a bandage on it, and you decide that, sure, you don't like this bandage, you can rip it off. It means that you are forcing the healing process. Or put it another way, you have a scab on your body because you had a cut. And you decide that the scab is going to peel it off. What is going to happen is you're going to irritate the wound because underneath is still not yet healed. And the scab is really dry blood enough that is oxidized by the air itself to prevent that protective coating, so that prevents bacteria from getting into the wound. But there are times you have bacteria getting in and you have infection. For me, we had a Band-Aid on this coronavirus, but we had to open the economy, we had to open schools, workplaces had to be reopened, and this and that, and so forth and so on. And we are forcing the stuff. And as it is just now, they are forcing this reopening come September. And trust me, be it resolved, my mind is already made up. If they're forcing anything on me, I have served 20 plus years in this system. I'm gone. I'm gone. And I'm saying that I'm not saying that I will not be a teacher, but guess what? Why is it that the work from home is but okay? Everton is saying that he's working from home, and I'm sure Everton is getting the job done even more than when he was inside, because at 8 o'clock, 9 o'clock, I'm sure him sit down when I'm something in system because in their yard. I understand. So it is very frightening. This morning again, I saw where was it a 13-year-old took the vaccine and went into a coma and is battling for life, right? Because they are now introducing the vaccine through Pfizer for children, because they are going back to school, and don't wear the mask. The mask is sabotaging, and is guys, come, we could do this stuff. The first times the differential of the second plus the second times the differentiation of the first. So it's the first times the differential of the second plus the second times the differentiation of the first. Here, what is happening here now? The first is my x squared. The first is my x cubed. So it's going to be the first. So because I call it the first, I'm going to write it back. The first, I'm going to write it back. Then I'm differentiating the second. Now remember from last class, I said to you, when you're differentiating the ln function, it's going to be 1 over x, and then you differentiate the x. It's going to be times by the differential of the x, right? So it's going to be 1 over x times the differential of x. So differentiating ln x you can have 1 over x. So when you differentiate x, you can get 1. So the answer is going to be 1 over x. So that's why I have this 1 over x here. Plus the second, every time I call the second, I write it back. Plus the second, ln x. See the second right here, so I write it back. Times the differentiation of the first. When I differentiate the first, I'm going to get 3x squared. Bam. So very good, Kimmy. All of this now is going to be all of that. What I can do here, what did I do? Okay, I did this multiplication. This x canceled with one of the x's here, so this gives me x squared. And of course, this is going to be just 3x squared ln x. Then, sir, couldn't you just add this x squared to the 3x squared to get 4x squared ln x? No, because you'd need a ln x right beside of this x squared, so you can't get 2 separate terms. All right, so your differential is going to be x squared plus 3x squared ln x. Very good. Then, sir, couldn't you factor out the x squared? Yes, you can. But guess what? The question asks for the differential at a given point. So because you have to go do a substitution, don't bother do that extra line because it's not going to give you any extra point. Use that extra line to just substitute. At a at 1, 0, it means that your x is 1 and your y is 0. Just let me put that there to remind you. Whenever you have a coordinate, your x value is written first, followed by your y value. So your x value is written first, followed by your y value. Right? So your x value is written first, followed by your y. So anywhere in this function I see x, I'm going to put 1. And anywhere in the function I see y, I'm going to put 0. Let me ask a question. Do I have any y in this blue here? Huh?
No.
No, I don't. No, and I'm happy that you said no, because I don't want anybody to say, sir, but f of x is equal to y. I agree, but this is not f of x. This is f dash of x. So there's no y there. So there's no need for me to use this 0. So if there's no y, don't worry about it. Just use what it is that you're given. So there are 3 x's. And so I'm going to go ahead and substitute. So look at what happens. Anywhere in the function here, in blue, I see x, I'm going to put 1. So it's going to be 1 squared plus 3 times 1 squared plus ln 1. Now, ln 1 is equal to what? Check it on your calculator for me, please.
Sir, what did you say to check a while ago?
ln1.
Okay.
Come on, you're supposed to know this now.
ln1?
Yeah.
Sorry, it says 0.
Very good. So ln1 is 0. So all of these 3, something here go to 0. So I'm just left with this 1 squared, which is 1. All right. So f dash of 1 is going to be 1. And that's what that is. A question like this is about a 3 marker, 4 marker, 5 marker in the exam. All right. I'm not going to go through this one just yet. The only other one I'm going to give you now is this other one here now. Just for, I have not even done it yet, so I have to go do it while you are working it. Because what I really want to do is the Maclaurin's. I want to do the Maclaurin's. I can close off this handout. Let me just be very cautious in saying close off the handout. There are 2 small areas in this handout that I have not done, and I'm going to ask you to hold me accountable. I have the information in the handout. So if you want, I've given you the handout. So if you want, you can read upon it. But I'm not doing it yet because there are some big boys down the road that never got trouble. The differential equation, the integration, multivariate function. So I want to trouble those first before I come back to them with a small something we can even use 15 minutes and do. All right. So just remind me that this is what it is that we need to do. So part 3, I want you to work part 3 for me. This question, I'm going to work it myself so that I can just go through it instead of working it when you are doing it. So start working for me, please, guys. Come on. Just a second. Okay, good. Finish?
Can you tell them I have, sir?
Yes, on bunches, please.
All right, now e to the 3x plus x plus 3e 3 of x ln 2x.
Say it one more time, Kimmy.
E to the 3 of x plus x plus 3e to the 3 of x ln 2x.
All right, so the second part, the second term
Mm.
is correct, but the first term, let me just check, man, because I'm doing it as we speak. Yeah, man, I'm correct. Look at the first times the root of the second. Differentiate the second from again, and look at that. Very close though. Very, very, very close.
Okay.
Congrats, actually. Proud of you. Kimmy, you find it?
No, sir, but because I have 1 over 2x, right? So how will you get to that?
Yeah, say it again. You have 1 over what?
2x.
Mm-hmm. 1 over 2x what? I'm gonna beat you now. I'm gonna beat you. I'm gonna beat you. Because if you tell me, okay, look at, is it where you are just now with that 1 over 2x? Look at it and tell me what it is that you're missing.
The difference about the 2x?
The 1 over 2x. The 1 over 2x is fine. But you're missing something. You're missing something with that.
I'm supposed to differentiate the 2x?
Duh.
Oh my god. Oh my god.
Duh. Come on, man, King. I know you know it.
There's that e to the 3x over x then.
Thank you, please, ma'am. Very good. You see? As so coming now, you know, one me, I live in a peace. You see when we get mental so quickly you do something? Very nice. Proud of you. Very, very, very nice. I'm very, very, very proud of you, Kimmy. And I want the rest of you to get to that stage where we can complete the stuff. All right, Kimmy, do me a favor now. Do the
Tell what I have.
Go ahead, hon.
Sir, here's some stuck coming off from here. So I have e 3x times 2 over 2x plus 3 e 3x times the ln 2x, and then I don't know where else to go from there.
All right, so you are mixing
Sorry,
the differentiation. I can pick out sense out of I want to say nonsense, but I can pick up some sense out of what it is that you have there. I'm going to ask you to look back at it. Just remember the first times the differentiation of the second plus the second times the differentiation of the first. You're not.
Oh,
you're,
all right. So,
Yeah, go on it. Kimmy, do the second part for the 100 bunches, please.
All right, sir.
Yeah, Romain, what you have?
Well, sir, so far what I have, basically have e to the 3x plus 3 to the e, but that's where I'm stuck.
All right, so the e
Might
to the
try-
3x is fine, but you're missing something.
Yeah,
You're missing
I've
something.
tried out of the LN expert, and then 2 expert differentiate.
Why does that's what stuff? E to the 3, e to the 3x. E to the 3x divided by 1 is just going to be two, 5, 7, and 2.
Sir, do me a favor, scroll up to the question I would do for. I want to look at something.
Give me half a second. Let me just finish this piece here. I'm in the last part of the calculation. 257 is equal to that plus 20.086 69.85. Come on. All right, so Cedar, oh, sorry, Cedar Everton.
All right. See what I'm doing. Oh.
What about the rest of you? Orlando, Shanice, Kimani, Candice, Kamal.
Sir, it's a carburetor engine in my brain, you know, sir.
Sir,
Take a while
all
to
right,
warm up.
something.
Oh, you wrote something in
Yes,
chat?
correct, sir.
Oh, sorry. You know, man. Lambda, I'm just seeing this. Osh.
Sorry, so you're saying only use what is given. Sir, why?
Yeah. Expressive Community College. But today is Saturday. Why Expressive calling me? Hold on, please. Thank you for calling Expressive Community College. Good afternoon. Good morning. turn up for what? For class? But he doesn't have a class today.
Yeah, why both people?
Him have a class today? Beautiful. You know, I have a challenge with this. I don't know if I spoke to him about it, but nobody came back to me with any information for me to inform the gentleman. Mr. Muirhead asked me for the name of the lecturer so that he could prepare the contract. But he never came back to me. And I doubt that because I had a chat with Mr. Nicholas, and he didn't mention of anything of the sort. So I'm sure he's not knowing of it.
I'd have laughed at before
No,
him
I
release
can
it to
tell
the
you,
people.
I mean,
You
the
know what I
audit
laughed
has been could be about 2 weeks ago
yeah?
now.
Before him start
That
tell them, say,
he said to
Chantalama!
me, to give him the name of the person who will be doing the class with the students from the better garden stuff. And I gave him the name, and he says that he's going to look at the contract with HR. Nothing more was said to me. Nothing more was said to me. And I guarantee you 100% nothing was said to Mr. Nicholson either. So I guarantee, so it's supposed to be a face-to-face class. And if it's face-to-face, it's unavailable.
Yo.
If it's face-to-face, it's unavailable. I can tell you straight, because we had that conversation one day this week. Because of his condition, he's not coming out face-to-face. His underlying conditions, he's not coming out face-to-face. So it don't even make sense I give you his number for you to call him, because it's going to be a categorical no. But I mean, Muirhead never said anything to me like it's going to be face-to-face. And I don't know who to find, who to assign, because the other, put it this way. Some of my members are senior, and some of my members have underlying conditions, and some of my members says to me categorically they are not coming out to teach in a face-to-face class. So I don't know what is going to happen, because as it is just now, I am in a Calculus 2 class online, and the truth of the matter is, I don't think mentally I'm even prepared to come out to the name. As a matter of fact, I can't read because I'm in a class right now that goes up to 12 o'clock. All right? But he's going to be unavailable. So if the class is online, I could possibly coerce him to do the class, but it's face-to-face, no. So I mean, what could happen, is that the students could come to the physical campus and utilize the computers there. And he, no man, oh goodness, no, but if that's a challenge now, oh Lord, no. Yeah. No, I see your point right there, Jesus. Guess what? We have to go back to the drawing table. Apologize to them for me. If they're already on campus, apologize to them. Let them go back home. Mr. Muirhead need to have a conversation with me on the matter. Or, because if it's going to be face-to-face, the lecture is unavailable. I can tell you that for sure, because we had a conversation about that in preparation for the new semester coming for the new academic year, that if any of those classes are face-to-face, count him out. He's fine, right? So I know he will have a problem with that. So I'm not even going to go to him because he told me specifically. So yeah, Muirhead have to come back to the drawing table, because I mean
I will finish
he never came back to me. I gave him the name and he never came back to me.
question.
So I apologize to the students for me, please. Yeah, apologize to them for me, please. Yeah, thanks much.
My brain now work, brethren. My brain buck.
Everton away again. Everton away again.
Ask me that. Listen, stop tell my bad word now, please. But they are
What
stressed.
a female was sorry did I talk to? What's your name? Kim or Kim?
Kimmy. It's Kimmy.
Kimmy.
It's her little nickname. Kimmy. Hey, Kimmy, you there? Sir.
I'm sorry about that. Yeah? Yes, please.
May hear the little laugh before you start chip expletives a while ago. But hear me, sir.
Oh Lord.
Sir, I'm gonna tell you what I have, right? I'm gonna start the differentiation, right? So he said the first, which is E3x times the second, the differentiation of a second, which is 2 over 2x, correct?
Say it again.
Plus So like you get it wrong.
No. I just need to make
Kind
sure
of
that
2
I
over 2x is the differentiation for ln 2x.
2 over. Yeah.
Where you get 2x?
No
Where you-
man, she right, man. Yeah man, continue.
Plus
Kim.
the ln 2x, which is the second times the 3, the first differentiation, which is 3e 3x.
Mm-hmm.
Time differentiation of the second.
Yes, sir. Am I correct, no?
I'm projecting the answer. I got lost with something to say, so I'm just gonna go ahead and project the answer because I did it.
Sir, so now the second, which is ln 2x, isn't that the second?
Hold on
The
there.
ln 2x, isn't it the second?
That's the second, yes, honey.
Rotted. Right, the damn question wrong. Yo, what do man?
Sir,
I
sir,
don't.
scroll up, must see what I go on.
Sir, start back from your question, from the top of the question, this, sir.
All right, so see here. So this is a question. So I'm calling this my first, and I'm calling this my second.
All right.
All right.
First get put back, differentiation
Oh, sir, I
is 1
didn't
over
put, I
the...
didn't, just put it 1 over x, sir. I didn't put 1 over 2x.
It has to be 1 over 2x.
Yes.
It has to be.
Everything is right, sir.
So what needs to happen?
So, sir, so I have to put, somebody have to put the, think of the complete differentiation, like you can put when they get the answer on the differentiate, which is then big 2 over 2x.
Yes, so 2 over 2x, sorry, break yourself. Let me spotlight it.
Sir, but you must say you have, sir, but
Say 2 over, this is 2 over 2x, you know. But 2 over 2x is 1 over x. 2 over 2x is 1 over x. So let me get the 1 over x right here, so. I just simplify this 2 over 2x here, so. To give me this 1 over x right here, so. And the 3x.
you know
right
what
here,
come
so.
across my mind, but just never, it
But
come
even if
across my mind and I say,
even if you had the 2 over 2x, you still get the same answer.
Sir, so we just calculate the multiplication, that's how we just cancel the 2 and put back the x.
Yeah.
Sir,
I never do it like that, sir.
Sir,
We
my
just do the
brain,
differentiation
sir,
the
my brain,
regular
nah,
way.
sir, don't move that,
When they
sir.
get the
Me I go-
answer,
Sir, you need to give it 2 more of that question, sir. My brain depend, my brain
I'm gonna tell you
depend,
what I get.
depend trackle now, it nah move.
All right, let me hear it.
Sir, I'm gonna tell you. You see that part, the sir, where you have the 1 over 2x times the 2, sir. Me never do that, you know, sir. Me just only put the 2 over 2x in the car. Trace the differentiation.
But guess what? Okay, move on because that is not wrong. It's just that you never can see it down. So move on to the next step. Tell me the other
But
step
sir,
because
when
you're
I
correct.
still, when me get that part, there, sir, me get the 3x ln 2x. Me get over the side, but when me get
You
the
get
next
you
side,
get all of this?
2.
Answer me, Peter. You get all of this?
Yes, sir. Me get all of that, sir.
And then what you have for your answer here is 2 over 2x e to the 3x?
Oh, me do that wrong.
Okay, that's the point.
Can we get 2x? We get 2e 3x over 2x.
You get 2e to the 3x over 2x?
Yeah, because you just multiply there.
And that's correct. That's what I'm saying. Peter, you're not listening, you know? You're not listening to what I'm saying, you know? So if you have 2e to the 3x over 2x, it is the same answer. It's just that I went ahead and canceled out the 2.
Oh,
so it will be correct.
What do wrong, you know? Because I'm stuck so long, I wonder what do wrong, you
It
know,
will be
sir.
correct. It's just that you don't simplify the stuff, but it will be correct. And then no, this is a part that I'm worried about. I'm not worried about this differentiation now. I'm not feeling this way. I'm not worried about this differentiation, you know. What I'm worried about now
Sir,
is
go back up, sir. I have to write off this, sir.
Okay, no problem.
I have to get it jamming on my head.
Hold on, let me just do something, please. Let me just talk about something while you write. Can you see it? Yeah. This is where I have an issue, Peter Gay. I have an issue now, not with the differentiation in blue. I have an issue now with the substitution because I want to see how you guys substitute this. So, by the way, Kimmy, look at what teacher has, Kimmy. You get the same thing, Kim?
Yes, sir.
Very nice, honey bunches. Kimani, you're very silent in class. Talk to teacher, Kimani.
Sir, I just
I'm gonna ask you a question.
Hold on, Peter. Hold on. Yeah, go ahead, Kimani.
Sir, I just in the second line we have the 1 over 2x times 2, sir. We did miss out the 2.
Right here, sir?
Yes, sir.
Okay. So remember now, and this is why, guys, I want you to tell me where it is that you went wrong with the question. You see, I mean, I wrote the question. I just did the solution, but I have to do the solution because I'm not physically in front of you. So I have to do the solution so that I can assist you with answering the question. But I also need to know where it is that you went wrong so I can correct it. So Kimani, what it is that you have done is to differentiate the ln x incompletely by just saying 1 over 2x. But remember, you have to know differentiate the function, and the differential of 2x is 2. So in order for you to have that complete differentiation, you have to differentiate the function. So it becomes a function of a function, so to speak.
Sir, stop talking about it and go through it step by step again. That me I talk about, sir.
All right, so before I go any further, if I like the way how I have it, sir, I didn't do any cancellation. If I am to do, because I would think I'm through. So if I am to do the substitution now, sir, my answer them would be wrong completely then.
How would it be? It wouldn't be wrong. It would be the same thing.
So because Truman never. Sir, because Truman never did the calculation. Yes, sir.
Calm down. If me tell you say your answer right, it's just that you have not reduced it. All it would be is that your substitution would be of a different value than what it is that I would have on the screen, but your final answer at 61.85 should come out to be 61.85. You're fine.
I'll do that right now.
Do that right now. Trust me, you're fine. All right. Before I go through again, I need to hear from. Okay, you're not feeling so well, so I won't call upon Candice. How you stay?
So it's just the 2 I did multiply by the.
Okay, all right. So now I know that is not just one person, but it's a group of you. Romeo, how you stay?
Sir, so why you put in the 1? What not? And is why you're looking? Oh, it's x alone. Okay.
It's only x alone. There's no y. Yeah. Kamar, how you stay?
So 1 over the x shouldn't change to 1.
Yes. Yes. Yes, Shanice, very good. Go ahead.
Sir.
Go on.
Sorry, because I was actually replying to you when you called to me. Sir, what do you want for see? Oh, you get the 1 over x e3x right there, sir.
Right here, sir?
Yeah, man. I want to already work on that again, please.
All right, no problem. All right,
that was my only issue.
All right, no problem.
That's why it was correct.
All right, fair enough. All right, so I would have asked everybody here. Okay. So this is a good opportunity now for me to go through. Are you seeing the screen?
I don't know why I'm last this morning.
No, don't worry about it. I'm going to go through now. Are you seeing the screen good, or you want me to expand it a little bit?
We can see it, all right.
All right, cool. Let's go then. So the question says, and I'm using another couple of minutes to finish off this. The question says, f of x is equal to e to the 3x ln 2x. A possible question for the exam. I don't know what CCCJ will send. A possible question for the exam. All right. So what is happening here is going to be the first times the differentiation of the second. So it is important. It is very important for me to identify which is the first, which is the second. Very important for me to identify which is the first and which is the second. So you've seen that second line, me writing the first and the second. Now, one of the things that I want you to be able to do and to agree with me on is line by line. Don't let a line pass by that you don't understand. So you understand how we name in the first and the second?
Yeah, man, sir.
All right, good. Next, let's go. Come, guys, I want all of you to be there with me. So it's going to be the first times the differentiation of the second plus the second times the differentiation of the first. The first is e to the 3x. Can you see my spotlight?
Yeah.
Yes, sir.
E to the 3x. So when I say first, me write it back. And when I say second, me write back it. All right? So the first, e to the 3x, I write it back, times the differentiation of the second. So I'm now differentiating the second, but it's an ln function. So Sir says to differentiate the ln function is going to be 1 over the function times the differential of the function. 1 over the function times the differential of the function. So 1 over the function is going to be 1 over anything that comes with the x. So it's going to be 1 over 2x.
Okay, so
times the differential, right? And so you're the third person in class now.
Yeah.
Times the differential of the 2x, which is 2. Right? So just remember, when you're differentiating the logarithmic function, it's always 1 over the function times the
Times
differential
the
of the
differential
function.
function.
All
Okay.
right. Plus the second. So you notice I call the second again now. Second, so I put back the second. Everything what the second is, I write it back. Times now the differentiation of the first. And the differentiation of the first is going to be differential of e to the x is e to the x. So anything e to the x is, I'm going to write it back. So see here, e to the x is e to the x. This is e to the 3x. So it's going to write back e to the 3x. And then I need to differentiate the function.
Hold on there. E to the x, right? Is e to the x, correct. So why is, so why all the 3 come over and
because I have to differentiate the function.
No. The 3 come over, cool. When the 3 comes over, isn't it supposed to go down by 1? No?
And that's, and yeah, and did it not?
It's like
So
it's like an
that's why
exponential function, you know.
No,
remember?
hold on.
No, you hold on.
The cube x or whatever. Cool? When you move that over, you differentiate that and move it in front of the e. Isn't that cube supposed to be now moved to a squared?
And that's the problem because they don't have a cube. You have e to the 3.
Gotcha. But if you look back on your notes on differentiation of exponential function, you will figure out that, yeah, man, that has somebody understand about it. As an exponential function.
So one, if it have a coefficient, that means it stands. All right, cool. No problem.
This is a teachable moment. No, I won't keep going because I got a teachable moment out of this a while ago. All right. So what Everton is saying is that he was looking at the 3x as cube, e to the cube, and he was thinking of reducing it and put it as squared afterwards. But it's no. The exponential function is a very special function. The logarithmic function is very special. So the things that you will do for the other stuff, you won't. Okay, put it this way. How I'm teaching you in the summer here is different from how I would teach a face-to-face class or a regular online class. Because I start from approximation. I don't know approximation. That is a little half a class. You understand? I don't do that. I haven't done that because I'm saying, let me get the big boys out of the way. Getting the big boys out of the way increases your opportunity. I don't have, the point I'm making, I don't have 15 weeks. That's the point I'm making. I don't have 15 weeks, so I have to take a different approach.
Sir, it'll work, sir. Stop trying.
No. I'm not saying that. I know that the approach is working. I'm just saying to you, I'm trying to put it in context with the differentiation. So there are exceptions to the rule. So just like how I'm approaching this calculus 2 in the summer is an exception to the rule. E to the x, the differential of the exponential function, the differential of the logarithmic function, is an exception to the rule of differentiation. How so, sir? Because when I'm differentiating the exponential function, the differential of the exponential function is the exponential function itself times the differential of the function.
Say it again. Say it again, sir. The differentiation of the exponential function is the
exponential
function itself times
the differential of the function.
I got you. Sir, where you go, sir?
To refresh your memory. The difference. So that's what it is. So the differentiated power times the exponential function itself. So it's going to be the exponential function times the differential of the function. So what I have here is that we can clearly see that the answer is the differentiated power times the given exponential function. So you have to differentiate the power and then put back the exponential function.
Yeah.
So see, try to place again, you know, e to the 3x is a question that we did before. E to the 3x is going to be the differentiated power. So the power up here, so you know what the power is, 3x. So you can differentiate 3x, so give me 3 times the given exponential function. So it can be 3 times e to the 3x, right? That's all. So remember that. So that's an exception to the rule. because and this is why we always say the differential of e to the x is e to the x. Sir, why do I say e to the x? Yeah, because e to the anything is the differential of e to the anything. Look at this one down here. This one says y is equal to e to the 3x squared plus 5x minus 7. My answer is going to be the differentiated power times the given exponential function. So when I differentiate the power, I'm going to get 3 times 2 is 6x plus 5,
yeah.
times the original question. See that? 6x plus 5 times the original question. So the differential, the exponential function is a special function. So is the logarithmic function. Sir, how so? The logarithmic function, when I'm differentiating the logarithmic function, it is 1 over x times the differential of x.
X, yeah.
So it times it, so it's 1 over the function times the differentiation of the function, which is pretty much the same thing. It's just that you're not finding the reciprocal. So this is the other one is a special function. It's a special case.
So what you're giving us now is a correlation of both of them.
Right. And oh Lord, where do I find it? I know I have the exponential, the logarithmic function in this document. Where do I?
Sir, I have the log down already in our book, sir.
Yeah, man, you're supposed to have it.
Part there, sir.
But it is what? All right, I lost my train of thought. But anyhow, so just remember now that the logarithmic function is 1 over the function times the differentiation of the function itself. So the differential of ln x is going to be 1 over x, is 1 over x times
the differentiation.
Yeah, man. You can't go wrong. No, this is strange. Why don't I
stop? Go back. Let's see something. Anna, eat that, sir?
No, I need to.
We did a while ago.
Yeah, that's what we did a while ago, but I need to go back to my original document. I don't understand why.
Sir, look like you need to link the lady there where you and her can go.
Who that?
On the GPS.
Trust me, man. She is something else. Turn right. I'm gonna turn right. I did say turn right. I said, don't shout at me, please. Don't shout at me, yes. All right. I will make a notation. Oh, it's right here. Good. So let me just put a narrative right here. So
we did that last week.
We did it. Yeah, man. But let me just put a narrative here.
So don't finish all of this now. Sir, you know what? Sir, you know what? Boss me for one little piece of food, sir. I can apply for your master, sir.
Jesus, trust me. If I could.
Sir, just give me a 50 pack, sir. Give them a 50 pack.
I could do that. I could do that. 50 US or pound?
No, man, a Jamaican more, man.
Okay.
I just want to show them, say, me give them a piece of food. I can't start them things, sir.
Yeah, trust me.
I beg, you know, sir. I beg everybody, me know, I call me some McCarthy. I say, sir, Mark, what go on? All right?
I see me saying, you need to. Answer shall be given. The differential of the logarithmic function is 1 over the function. 1 over the function times the differential of
Shanice, you know, your friend one little grant. Shanice.
What? Where's that?
Remember, me rich people work at your workplace and all that.
Okay.
Boss, yes, sir. They can't talk to. Here we go. Talk to the CEO, see, and tell them, say, yeah, think about how the company can give back to the community. Is it? You know, and you know, is it? I can move on me that there's still enough people. If you don't want, you know.
You're the plan. Me need to go open one myself too. Look at this, guys, and tell me if this makes sense.
Yeah. The differential of the logarithmic function is 1 over the function times the differential of the function itself. Yes, sir.
So see, turn. So for example,
that's never my problem. The other part of it, my problem.
So for example, you have ln x is 1 over x times the differential of the function. And the differential of the function x is 1. So we can get 1 over x. So this is why you often hear me say the differential of ln x is 1 over x.
You know why? You know why me get mixed up as a serious the way they are jamming in my head? I was saying, all right. When me I got differentiate, so the one I got there in front, but you change it round. We put the one in front of the fraction. So you have 1 times the fraction. And that is why I get it out. But I know I write it down my way still. Because you rearrange it. So whenever is a thing with me, so whenever I make a differentiate, sir, I make sure say it all because it's the way I first learn. You move it over and it always falling with before. So there you go.
All right, so watch this here now. As a recap,
yeah,
the differential of the function, ln x squared, it's going to be 1 over the function,
so yeah,
1 over x squared times the differentiation of the function. And when you differentiate x squared, you can get 2x.
2x.
Right. So just remember that it's 1 over the function times the differentiation of the function itself. And you're good to go.
Yes, sir.
You're good to go. Right. So remember, we did this actually, you know. So I'm just
yeah.
I just want to make sure that you have it packed. All right. Let's go.
Sir, I have a dilemma, sir.
Who?
I have a dilemma.
What happened?
I wonder if I forgot take 1 year and do back some certifications, or if I just try and go straight in a master's.
The truth of the matter is certifications are always very good, but also you get the chance to do the masters. Go ahead and do the masters.
Sir, but you still not say yes, you're gonna give me a loan yet, sir. That's my problem.
But I mean, you have people like from being in the class, you know what my little 2 pounds.
No, sir, I hear 2 pounds more, sir.
No,
you are listen.
No. Come, let's go. Let's go.
He's a doctor? Which hospital him work? No, man, no. These men are doctors of the mind, my friend. They impart knowledge in marvelous ways.
Let f of x be equal to 1 over x plus 1 all squared. 1 over x plus 1 all squared. Determine the Maclaurin's expansion of this. No, remember we did Maclaurin's expansion already? We did Maclaurin's expansion, you know. But here what happened now. This says including the term in x to the 4th. Now tell me the x to the 4th part of it. What does that signify? What the x to the 4th tells you that you must do. Come on, don't fail me now. Come on.
Maclaurin's function. I think that's the first thing we do.
What?
They bring it to the 4th
Very
like
good.
have.
Like you have what? I hear you say something, Shanice. Like you have what? All right, go again.
Sir, me say it, nobody.
No. I was sorry. I called around you. Peter again. Shanice, you said the correct thing. Say it again, Shanice, please. Shanice, talk to me now and stop being Freddy.
No, sir, it wasn't me, sir.
Somebody said the correct thing a while ago. Who was it?
Peter gave you that Chinese.
Huh?
34th derivative.
Oh, thank you, Kimmy. Oh, it was Kimmy, right? Thanks, Kimmy.
Bright people, I'm not enough.
Yeah, man. So let's go with this one. Because remember, you know, I am not doing the differential for you. Your problem with the class, the problem I have with the class is that you don't know how to differentiate. That's the problem, you know. That's the main problem. And it's not everybody in the class. But generally, that is the issue. So let's go. Let me just tell you what it is that I want you to do. I'm going to give you a few to do it, and then we'll go through the stuff. It says, let f of x be equal to 1 over x plus 1 all squares. That's the given function. Determine the Maclaurin's expansion of f of x. What is f of x, sir? 1 over x plus 1 all squares. Up to and including the term in x to the 4th. Oh, x to the 4th. No, it means say, including the term up to x to the 4th, that I have to go down to the 4th differential. So I have to differentiate this thing multiple times. All right. So what I want you to do for me, now, I'm going to give you 5 minutes to do it. I want you to differentiate this function 4 times. You're going to find f dash of x, f double dash of x, f triple dash of x, and x to the fourth of x. On your mark, get set, go.
Sir, this is the question then when you say whenever the Maclaurin's in it, did I get all 15 marks or 20 marks to the question, sir? Is this the type of thing, right? Where you have to differential.
Sir. Yes, sir.
Sir, I can't drink tea.
Yo, people, how we start out this? Are the denominator times the differentiation of the numerator times the numerator times the denominator?
No, a minus. I think the quotient rule. The quotient rule I use.
Gotcha. Cool.
So the denominator times the differential of the numerator minus the numerator times the differential of the denominator over the denominator all squared.
So when we get to the first derivative, we get -1 over x plus 1 square. That right?
The first one?
Yeah.
No. 2.
It wrong?
A -2 over x plus
minus
1. Repeat where?
-2. I have -1 over x plus 1 square.
No. Yesterday, tell me a second part after the minus sign. You have the numerator times the differential of the denominator times the differential of the numerator minus the numerator times the differential of the numerator. The differential of the numerator over the denominator. Let me hear where you have when you differentiate x plus 1 squared, where you get over the other side.
I never at the x plus 1 square, I never have it square. Shoot.
So
yeah, because when you carry over the 2,
you get 2x plus 2.
No, 2x plus 1. Remember, say the -1 I power, so it now gonna have no. You're not trouble a bracket then because it can use from from the denominator. You're not trouble, you're not expand the bracket.
You're not gonna expand it, you're gonna square it the same way.
Remember, say at the power rule, you know, say -1. So you carry over the 2 at the front, you have 2 one bracket x plus 1, and you have -1 from the 2, so 1 are going left.
Why -1?
And then you put times the differential of the inside of the bracket, which is 1.
Oh, all right, I get you.
Oh, yeah.
All right.
Yeah, at the power rule, I want the 2 one bracket plus 1, like it times the differential of the inside of the bracket.
Obviously, you finish?
Yes, sir.
All right.
Then I do the second part.
Very nice.
With the 2 factorial.
Very nice. As I said before, my concern is with your differentiation. All right, I give you another, say 3 minutes, and before I do the start solution.
Guys, what is the second step again? The first step of your differentiate, the second step you rearrange it, right?
Go on again.
So the first step, you set it out, do the differentiation and everything. So it's going to be the denominator times differentiation of the numerator minus the numerator times the denominator, the differentiation of the denominator, correct? And then you rearrange after. Hello?
You not understand. Yeah, I don't understand.
All right, tell me what you have for the first line where you write out the
I have the numerator, the denominator.
You have x plus 1
squared
that
times the numerator differential as 0 minus the numerator, which is 1, times the denominator, which is 2, open bracket, x plus 1, close bracket, times the differential at the inside of the bracket, which is 1.
2.
1. X is 1 after differentiate. The bracket is 1. And then you put all of that over the denominator squared. So you're gonna have x plus 1 squared, open bracket again, squared. So yeah, squared everything.
X plus 1, now man, x plus 1 squared, then squared again. All right, cool.
Yeah.
All right, so that's a couple of differential of the inside of the bracket. All right, that's where I went. That's where I went. Why the hell? I don't know, brother. I don't know what to my brain today. My brain not work at all. So then I want all and can't come out. All right, thanks.
Kimmy.
Yeah.
Say, where you get, you say 1 over x plus 1 square, not square, cube.
Which?
For the first one.
-2. They get the bottom part.
Multiply.
Yeah. Yeah. So the 2 times the negative 1.
And then the denominator what again?
X plus 1 cube.
Oh, I get that then.
Yeah.
It's just You finish?
Me?
You finish?
Yeah, I'm finished everything now.
Or you go about the secondary, the
second one. All right. So you see the -2 over the x cube, x plus 1 cube, that are going to be a second derivative. That's way I go start work out now. So that's going to be a next value we are going to use to do the second derivative. And do it the same way or you work the first one.
So now come like the way name the one. So when I have the -2 over x plus 1 3 plus the 1 over x plus 1 square, right?
No, I just the -2 over x plus 1 cube we are going to use now for your second derivative. And I need nothing else, just that.
And think that and think differentiate that, right?
Yes, so that has to be a second derivative when you differentiate the -2 x plus 1 cube.
All right then.
Okay, very good. Very good. So let's go. So
so wait till we finish now. I get it now one week by myself.
All right, then cool, no problem. I'll
give me about 5 more minutes.
All right, and I really hope that the rest of you using the same time. All right, go 1.
Give me.
Yeah, we say.
I get for the second one.
6 over what is that? X plus 1 to the fourth power. That you have?
I have to the third power. Oh, I get that.
3 times 2.
What are you talking about?
What? Oh, me get that to know. Oh, me get that because. Oh, me get that through the denominator, which will be x plus 1 square. But then one time you think that it's
I think you're not supposed. Remember, saying you're not supposed to mess with the denominator. You know? Am I correct or am I wrong? You're not supposed to mess with the denominator.
Let me do something more. When you differentiate it, you wouldn't get 3 bracket x plus 1, but then you're gonna have the 2 then times the differentiation of the inside one.
Yeah, that part there.
Huh?
That part there, right? So you say the 3 open bracket x plus 1 squared times the 1. That's correct. And you have the numerator, which is minus 2. You did it, so yeah.
The numerator would be, it would be x plus 1 to the 5th power. Who would I have a set?
The people them they are foreign living in their background. And the TV are people that talk on bread. I want to know.
So it would be x plus 1 bracket 5 to the 5th power.
The 5th power?
Yeah, it would be that.
Last, you know, brother. I don't know why I'm last. So them just not fire.
Come now and talk to you ever time. Get away, you know?
No. Oh, sir. Sir, you there, boy? I move the mouse. Yeah, man.
I'm right here.
Sir, my
so
last.
You listen to me and saying that, sir, I'm gonna tell you.
No, I hear you know. All right, do me a favor, because I hear you know. Give me an opportunity to just go through this question. I have one more of these questions to give you because I need to move into something
Okay,
else.
sir, dear thing. All right, dear thing.
Okay, so so we're given a function, f of x is equals to 1 over x plus 1 all squared.
Yeah.
We are asked to do Maclaurin's expansion. Maclaurin's expansion predominantly involves differentiation. A whole lot of differentiation and substitution. Matter of fact, everything that we have done so far, Newton-Raphson, differentiation. Maclaurin's, differentiation, right? So these are what we're looking at now are the applications to differentiation. So we're looking at the applications of differentiation for this section. I need now to move to the application of integration, all right? Because it's calculus. Calculus really talks about differentiation and integration. One is the opposite of the other. And we see how the pair of them intertwine in order to, you know, to get things going. Funny enough, while I was listening to you, I was watching a video and the guy was talking about signs. Now, a lot of these scientists have to use what it is that we're studying in order to get what it is that they want. So we have to differentiate the function to investigate. It is exactly what you're talking about. Investigate what happens at the first derivative, investigate what happens at the second derivative, investigate what happens at the third derivative, and investigate what happens at the fourth derivative as it relates to this question. All right, so what is going to be required of me in the first instance is to, well, as I said before, so Maclaurin really speaks about the differentiation of the function and find the zeros of those functions, right? So the very first step is to find the zero of f of x, right? So, and of course in doing the solution. So we're gonna find the zero of f of x. So anywhere in the function f of x, I see x, I'm gonna put 0. Anywhere in the function f of x, I see x, I'm gonna put 0. So f of 0.
Hold on. Sorry, why you start out with the 0 again? Point it out for me again, please. It was given. It was given.
The f of x was given, you know. But let me just go back.
The zero. Why is it 0? Why is it 0?
Yeah, man, that's what I'm going to just refresh your memory. I know you know it, but
sir, I'm not fire to that, sir. I don't know what.
Too much party last night.
Oh, no party.
What a mistake. Anybody know the rest of that? Sure, no. Young people, you know. You know the commercial, them said too much party last night.
Which party?
What a mistake.
What party can?
All of our young people, right? Andrews, of course.
Sir.
All right, let's go.
Sir.
All right, look at this now. So in order to answer your question, Everton, we have to find f of 0. So I have to find f of 0, then f dash of 0, then f double dash of 0.
Oh, that's what you're referring to.
Yeah, man.
Okay.
So I am not only trying to find the derivatives of 0, but I also need to find the 0 of the function. Right? So I need to find f of 0. Then I find f dash of 0 of x and so forth and so on. So my f of 0, my original function being equal to 0. Anywhere in the function I see x, I'm putting 0. So this is 0 plus 1 is 1, don't? And 1 squared is 1, and 1 over 1 is 1. That's why I get f of 0 to be equal to 1. Then now I need to find f dash of 0. But before I find f dash of 0, I have to first find f dash of x. Good. So I have to differentiate this function now. Differentiating this function. So watch it. It's the denominator. The denominator times the differentiation of the numerator minus
the numerator
times
the differentiation of the denominator.
All over the denominator.
All over the square.
Very good. I'm happy that you know that. Knowing that though is not enough, I want you know to apply it. So that's very good. I give you kudos for
that.
I give you kudos for remembering that. Let's go.
The first function alone.
So this piece, the denominator right here times the differentiation of the numerator, the differentiation of a constant is equal to
the constant.
0.
0. Yeah.
So all of this piece here goes minus the numerator. Now I need to differentiate the denominator. So remember, it's a power rule here. So it's going to be 2 in front here, so
yeah.
And then x plus 1, and you subtract 1 from the power, so it's to the first power.
Yeah.
And then I have to differentiate what is on the inside, which is going to be 1. All over the denominator squares. Now remember.
Yeah, you have to square that again. You have to
very good.
Or the outside. Right?
Very good. Very good.
Can't believe it, star.
You can't not remember that you have to square this piece here. So now, so what happens now is that I'm going to have negative 2 over x plus 1 times x plus 1 to the 4th.
Just give me.
But sir, this x plus 1 to the 1st can cancel it one of the x plus 1 to the 4th down here. So yeah, man. So that's why I need x plus 1 to the 3. So we have negative 2 over x plus 1 to the 3. Did anybody get this piece here?
Yes, sir. Things around, so.
No, man. Hey, Shan. Oh, I have a confidence in the mums. All right. So, so that's what I get for my first derivative. All right. Now, who was asking a question earlier? Peter Gay. You understand now why it is very important, Honey Bunches, for me to always simplify my answer, and I say this to you in the backdrop of you having the 2 over the 2x for the one of the
Yes, sir.
questions, right? Because if you don't simplify, and in that case, in that example, it wasn't an issue. Honestly speaking, it wasn't an issue because you're going to go and make a further substitution, right? In this year example, even though you are going to be making a substitution like you did in the first example, where x is equal to 0 in this case, you're going to be using this function to differentiate to get the second derivative, the second derivative. So this is what you're going to differentiate now to get f double dash of x. So you have to always make sure that you put it in its simplest form every single time.
Sir, I get you. All right. Roll up, go back a little bit. Go, no. Go. Yeah, over back to the first derivative here, sir. Right? May I go through it in my head? I'm still a buck. Why? I don't know. How you get the 0 here, so?
The differential of the numerator. It's a denominator.
Yeah.
Which is this.
Yeah.
Times the differentiation of the numerator. And the differentiation of the numerator is a constant, so it's equal to 0. Minus the numerator is minus 1.
Yeah.
Times the differentiation of the denominator.
Yeah. All right. Cool. Gotcha.
Yeah.
Gotcha.
As I said before, and I don't think you guys are doing enough of this. And let me just stop and say,
sir. Me sit down, sir. 4 hours out of the week, sir. And just say, all right, I'm gonna go through this. I'm gonna go through this. And then but just turn up blank.
Yeah, don't worry about that part yet. But let me just say this on a wholesale basis. This is not geared specifically to any one student. Uno know, say me check for uno. As I said before, when I looked at the grades, the combined grades, I was the one who went and said, I know some students are finalizing. Let us increase their opportunity to finish off. And I'm going to tell you what I'm sensing. And I'm in the system too long to be sensing something incorrectly. A lot of emphasis is being placed on the weekday courses. A lot of emphasis are being placed on the weekday courses. And I'm going to tell you what happened. Because those courses, for the most part, you are doing for the first time. This course, you would have done already. So you feel that you don't have to spend much time in this course because you know a little bit of something already. So you have to spend enough time for your troubleshooting, and you have to spend time on your telecommunication, and you have to spend some time on your capstone project, and you have to spend time on this and that. And so, no, I understand the calculus, man, because we do it already, so we just have to go brush up. And as a result of that, much energies are not being placed on the calculus. So this is what I find. Like last week, I wasn't upset. I really wasn't upset. But when I left class, I sat down and I started reflecting. And I said to myself, what a plan it is every Saturday, where when I'm doing the review class end up becoming a teaching session. And I say, you know what? Let me see what will happen today, Saturday. And I come back to class today and I recognize that the 4 hours that we spent on just looking at the differentiation, it is still not fully understood. And I am going to have an issue with that because there are, and that's why I'm saying I'm moving on, because there are areas that I must complete. We write a paper a long time, you know. Your paper was submitted long. When I made a recommendation and your head of school agrees with me, I started writing the exam paper. Before I started teaching you guys this Saturday, your exam paper went in that very week. Maybe about the Tuesday or Wednesday of that week. Your exam is already written. Same to you. You have to be conscious to spend some time on the calculus too, or else, God forbid, what is going to happen? And I don't want to say it, but I'm going to say it. What is going to happen? The other courses you're doing in a weekday, you will pass those. But you will get a shock of your life. It's like how Grant Holloway swears him they're going to gold medal for the 110-meter hurdles. And the whole of the United States screamed they're going it. 50 meters in the race, Hans Parchment started close on him. Took him by surprise. To the point when the man reached the finishing line, he turned over and looked to him right because he smelled Hans Parchment. And this is what is going to happen to some of you. You're going to say, sure, we're all right with this. And God forbid, you're going to one course short to graduate. It would have wasted my energies in terms of my Saturday mornings. It would have wasted your energies. I'm going to ask you again, spend some time on the mathematics. I cannot be going through the differentiation with you guys every week. The differentiation is what is causing the problem. And I'm sure when I move into the applications of the integration, I'm going to have similar challenges. Come on, guys. Come on. This should not happen. And that's why I'm moving on. I am moving on, knowing, very cognizant, that you guys don't know how to differentiate and differentiate well. But if I give you the differentiation, that's all we need to do for the calculus 2. I'm never fail the exam, and I would have failed you. I went ahead. I had previously created a YouTube channel. I placed the recordings for the Saturday classes in the channel. I shared the link with you. All I'll ask you to do is to subscribe, so at least when this recording becomes available and I put it through, you'll be notified of the new stuff in the stuff. Go through, I've labeled the sessions. I've had the channel for some time now. I've labeled the sessions. Look for Calculus 2 Summer 2021 and go through the word. I talked to you last week and I'm talking to you today again. Don't play with the mathematics. The mathematics is not a reading subject, you know. You can go read and say, yeah, man, I saw this word and can explain it. You have to know what you're doing with this stuff, or else it will take you by surprise.
Sir, put the YouTube channel, a link in the chat now, sir.
No, Jesus.
It's in the group.
It's in the group, man.
To the group.
You might see the group, man. It's in the group, man. I sent it in the group already.
All right.
Thing about it is that I don't know it offhand, so yeah. I forgot to look for it to go type it myself, right? But all I'm saying to you students, please, I don't want to come next week. And I mean, even if I have to stop the class next week to talk to you again, I'm going to do it. Because I want you guys to know where you're at. Let me just put this in now that I'm here. I said to you at the start of the class that we need to have a conversation about our mid-semester exam. I'm ready for the mid-semester. But guess what? Maybe that's what I need to do, you know. I may need to tell you that the mid-semester is going to be. We may need to set a date for the mid-semester so that I can get you guys to understand how to differentiate, because that is my main problem with you guys. This is what I may need to do. So I'm going to say to you again, please, you have to be doing some work. Now, here what is going to happen. Here's what's going to happen. The links, the recordings are in the you have access to the recordings. And I did it this way because I don't want to be having to send the recordings to people, you know, every time I'm after, you know, and then they say, sir, you can't resend us. I create a space so that the recordings can go to that space. If you want it, you can know where to find the recordings. All right, hear me out. Now go find some time. Sit down and go through the recordings again. When you can fast forward, so when I'm not watching it, listening to the recording, I'm watching it, whatever you want to do with it. This piece up the top, if you want to be motivated, you can listen to it. But if you're looking for something specific, you can scroll to it. So you don't have, the point I'm making, you don't have to sit down for 4 hours to look at the recording. You can scroll through the recording and you can pick up at the point where it is that you need to pick up. All right? One of the things that I'm going to do sometime later is to create a Christine version. So I give it a raw recordings now. Sometime later, I'm going to go back and purge recordings. I can pick up all of these talking and just put a Christine stuff together so that I can keep an archive of this for students. But students, come Come on, I want when I do the stuff, you guys can pass the course and move on and move to other things. I am not impressed for the most part. But no, I have said it enough. I can't overemphasize it. There's no love lost between us, you know. But I have to tell you what it is. All right, let's go. So the differentiation, when you're differentiating a quotient, remember, it's going to be the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. All over the denominator squares. Sir, if the denominator square, do we still have to square it again? Yes, you must. Because the formula says all over the denominator squares. So let's go. One more time. I'm differentiating my f of x to give you my f dash of x. Let me just see if I can color code this stuff. All the ones in blue is what I have to differentiate to get the next one. So I'm differentiating my f of x in order to get my f dash of x. The denominator, x plus 1 all squared, see right here, so? Times the differentiation of the numerator. The numerator is a constant. The differential of a constant is equal to 0, right here, so. Minus the numerator is 1. So minus 1 times the differentiation of the denominator. In differentiating the denominator, it's going to be this 2 in front of this. Then I'm going to have my x plus 1. I'm reducing this by 1. And then I'm going to differentiate what is on the inside. Let us check. The 2 goes in front, see it right here, so. Then it becomes x plus 1 to the first. Why to the first, sir? Because we're reducing this 4 by 1. And then this one came about because we differentiated the x plus 1. The differential of a constant is equal to 0, and the differential of x is equal to 1. This one here, all over the denominator squares. It is x plus 1 all squares squared, which gives me x plus 1 to the 4th power. All right? Now, everything right here, so, goes to 0. Why, sir? Because 0 times anything is 0. All I'm left with is minus 2 times x plus 1. But minus 2 times x plus 1 over x to the 4th can be simplified by canceling one of these x plus 1 up here with one of the x plus 1 down there. So I'm going to have, instead of 4, I'm going to have 3. See it right here, so? So I'm just going to have the negative 2 times x plus 1 to the 3rd power. All right? This is my differentiation in its simplified form. Having differentiated that, then I now need to find the 0 of it. Sir, why? See it here, so? F dash of 0 of x. This is what Maclaurin's expansion says, you know. So I remember when I was studying this in high school, all I needed to do, you know, is to study this formula. So once I knew this formula, I know what I need to find. F of 0, you say, okay, fine. I have the original function, put 0 in that, put on the answer there. Then f dash of 0 of x, it means I have to find the first derivative, find the 0 of the first derivative, and times the answer by x. The one here, I have to find the 0 of the second derivative. When I find the 0 of the second derivative, I'm going to divide it by 2 factorial, times it by x squared. Find the third derivative, find the 0 of the third derivative, divide that answer by 3 factorial, which is 6, times it by that. So I know what the formula is, and I worked with it. But you see the difference? I knew how to differentiate. Any function it gave me, I could differentiate it. How, sir? How you were able to do that? I grabbed the one book. Yeah, we never have editor solve them time. We never have computer them time there. We never have internet in Jamaica them time there. You understand? And just practice. Just practice the differentiation. Just practice. Something that you guys are lacking, but I'm sure after today's class, you're going to be practicing. All right, let's go. So this is it. I'm finding the 0 of this f dash of x. F dash of 0. Anywhere in the first derivative, I see x, I'm putting 0. Watch me. 0 plus 1 is 1. And 1 cubed is 1. And negative 2 divided by 1 is negative 2. That's why I get this negative 2 right here, sir. That's why I get this negative 2 right here. Watch me now. I'm differentiating. I'm finding the second derivative. I'm using this function to differentiate it to get this function. So the step here in getting it is the denominator. X plus 1 cube, see here, so x plus 1 cube. Anytime I call the denominator, I write it back. Anytime I call the first, I write it back. All right? So it's a denominator, x plus 1 to the third, times the differentiation of the numerator. I am now differentiating this. When I differentiate this as a constant here, I'm going to get 0. So it becomes 0. Minus the numerator, which is a negative sign. So not because there's a negative sign here, you're going to leave off this negative sign. No. It's minus the numerator, but the numerator is a negative 2 times the differentiation of the denominator. Watch again how we differentiate in the denominator. It's 3 in front here, so see it right here, so times x plus 1 to the second power. Why to the second power, sir? Because we're reducing it by 1. Okay, so I remember. So it's supposed to be x plus 1 squares. See it here, so x plus 1 squares. And then I'm timesing it now by the differential of the inside. When I differentiate on the inside here, I'm going to get 1. So that's how I have this 1. I'm saying to you, if you take your differentiation step by step, nothing can hold you back. It's the first times the differentiation of the second plus the second times the differentiation of the first. It is the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. You have to take your calculation step by step by step by step. So watch me now. So when I'm differentiating here, I'm going to have 3 go in front of here. So I'm going to write back my x plus 1 because I'm reducing the power by 1. So it becomes 3 times x plus 1 to the second power times 1. See here, so 3 times x plus 1 to the second power times 1. All over the denominator squares. No, sir, why does I not seeing it put anything like here? So no, because a big school with a no. I'm going to show you this right here. So because what I want you to recognize now is that the denominator squares is going to become 3 squares. And when we square the denominator, we're multiplying here by 2. So see here, 2 times 2 is 4, and this 3 times 2 is going to give us 6. So that's why this becomes 6 here. So again, everything here goes to 0. And then now, this negative 1 times this negative 2 gives me a positive 2 times this 3 gives me a positive 6 times this 1 still gives me a positive 6. So what I have is 6x plus 1 all squares. But this x plus 1 all squares can cancel with 2 of this down there to leave x plus 1 to the 4th. See here, so x plus 1 to the 4th. So that's why I have the 6 over x plus 1 to the 4th power. Having done that, I'm finding the 0 of the function. 0 plus 1 is 1 to the 4th power is 1. 6 divided by 1 is 6. I'm going to pause right there for you to look at it and to ask me any questions so far before I go through the rest of the question. Are you okay with that so far?
Yes, sir.
All right, good.
Yes,
Now,
sir.
all right, good. Now, if I'm going too fast with this differentiation, just let me know. But students, I beg of you, please. If you don't want to do it for yourself, just do it for me, you know. Please. I really want you to pass the course. But I need to see evidence of work on that paper when I mark it that you've learned. Let's go. This is what I'm going to be differentiating in order to get the f triple dash of x. So I'm differentiating the second, I'm finding the second, I'm differentiating the second derivative once more in order to get the third derivative. Sure, why we have to go so far? It says up to and including the term x to the 4th. So this is an indication, it's a hint where we are going to be stopping. We're going to be stopping at x. Then, sir, then suppose they're never giving out thing. They have to tell you before go, or if you can go on and go on and go on and go on. Sometimes, however, when they don't tell you, it means that the differential terminates. Sometimes they don't tell you, but the differential terminates. It's not a fraction, it's going to be a polynomial, and you can differentiate a polynomial a definite number of times. So if I give you a polynomial up to the 3rd power, I can only differentiate that 1, 2, 3 times, because the fourth differential is going to give me 0. So unless I give you a polynomial, they may not tell you what to do, because after a certain time, you're going to end up with a constant. I'm going to differentiate that constant to get 0. So you just stop right here, because 0 times any place is going to be 0. All right, let's go. So I'm differentiating this. This here is going to be the denominator. The denominator. In time I call the denominator, write it back. The denominator is x plus 1 to the 4. The denominator, see to yourself? The denominator times the differentiation of the numerator. When I differentiate a constant, I'm going to put in a 0. Minus the numerator, see here? Minus the numerator says a minus 6. Times, this dot means times the differentiation of the denominator. So let us differentiate the denominator. It's going to be 4 in front here, so times x plus 1 to the third, see here? 4 times x plus 1 to the third times now by the differentiation of the inside. Differentiation of the inside is going to be 1. All over the denominator squares. So it's going to be x plus 1 to the 8th power. Remember, this is x plus 1 to the 4th power because we're going to multiply the powers. Recall, a to the m raised to the nth power is going to be equal to a to the mn. We are multiplying the powers. So that 4 is going to be multiplied by 2 to give me 8. So this is what I have. I'm simplifying this. And when I simplify this, this cancels with that. That gives me 0. Oh, sir, x plus 1 to the 4th times 0 is equal to 0. Is equal to 0. Then I'm going to be evaluating this. Negative 6 times 4 is negative 24. And negative 24 times 1 is a negative 24. See right here, sir? Negative 24. But sir, you leave out the x plus 1 to the third. Not quite, you know, because we have x plus 1 to the third up here, but I have x plus 1 to the 8th down here. So something can cancel. So all of this can be cancelled and leave only 5 down here. Oh, sir, no me see it, come on. Because down in here, so I have 8 of the x plus 1. So I only have 3 of the x plus 1 up at top. So each of the x plus 1 up top, 1, 2, 3, we cancel with 1, 2, 3, so I'm going to leave it 5 down here. So that's why I have the x plus 1 to the 5th power right here. Got you, sir. But sir, we have to find the 0 of the function. Thanks for reminding me, because that's supposed to be f triple dash of 0 and not x. So similar to this one. So what is going to happen now is that I am going to put in 0 right here. So 0 plus 1 is 1 to the 5th is 1. So negative 24 divided by 1 is negative 24. So I'm going to have negative 24 right there also. I'm going to have negative 24 right here, right? We have one last one to go. Sir, how you know, sir? Remember, they said x to the 4th. They said x to the 4th. So again, I'm using the third to differentiate to get the 4th. Sir, you couldn't use the second to differentiate to get the 4th. No. When I differentiate the second derivative once more, I'm going to be given the third derivative. So the only way I can evaluate the 4th derivative is by using the third derivative in order to get the 4th. I can't use the first and just jump and differentiate it to get the 4th. No, I have to use the third one to get the 4th and so forth and so on. So let's go. In this one, it's a denominator. In time I call it and write it back. The denominator, x plus 1 to the 5th. See just so? X plus 1 to the 5th, the denominator, times the differentiation of the numerator. When I differentiate the numerator, I'm going to get 0 because it is a constant. So that's when we get a 0 right here. So minus the numerator. Oh, sir, I see the double negative signs come back because it's minus the numerator, but the numerator is negative. Very good. So we write it back. Times the differentiation of the denominator. Let us differentiate the denominator. But sir, I realize that the same thing I do over and over again because of the same method of the differentiation I do. Absolutely. The 5 here, come in front of this here, so see it right here, so you can reduce this by 1, see it right here, so and then you differentiate inside here, so see it right here, so absolutely. all over the denominator squares. Yes, sir. And you did say that when we're doing a question like this, in this particular case, x plus 1 to the 5th squares is going to be x plus 1 to the 10th, because what it is that you're doing, you're multiplying the powers. Absolutely correct. That's why I get the x plus 1 to the 10th power. All right? Then I'm simplifying. Remember, all of this goes to 0. All of this goes to 0. All of this goes to 0. And then I'm going to evaluate that. And I multiply two negative numbers and get a positive number. So negative 1 times negative 24 gives me a positive 24. 24 times 5 gives me 120. And 120 times 1 gives me this 120. Sir, you leave off the x plus 1 to the 4th. Thanks for reminding me. This x plus 1 to the 4th is going to be divided here. So I'm going to reduce this by x plus 1 to the 6th. And this is why I have this x plus 1 to the 6th right here. So having completed my differentiation, I'm going to find a 0 now of f to the 4th of x. So anywhere in the function, I see x at 0. So 0 plus 1 is 1. And 1 to the 6 is 1. So 120 divided by 1 is simply 120. And that's what.
Sir.
Yes, please.
When you move the blocks up, I look at something, show you something where I realize.
Go ahead.
All right. Once you differentiate the first one, all right? The first numerator, the second is going to be, depending on the number, well, I think is a pattern. The second numerator is going to be the inverse of the one that is above. So you have negative, positive, negative, positive, negative. So while you're working, you can, well, it's just, I'm going to try it, where I'm going to just work it, and then I will then just make sure that the first one is right, and then alternate the signs with the differential, the first, second, and third, fourth, the derivatives. Then once I'm sure that the first derivative, the first derivative's denominator's power is correct, then I'm just going to increment by 1.
Okay,
hold on, sir. I'm not done yet, sir. Then increment it by 1. My hypothesis to it, scroll down a little bit. The formula, sir. If you look at the formula, right? The formula literally tells you how it is going to turn out for the denominator. It's going to be 2, then 3, then 4, then 5, and it goes on the factorial in that manner. That is how I looked at it a while ago. When I'm not, so I can use that to verify my answers. It's supposed to be a negative. It's supposed to be raised to this power once you do the differentiation. Just a quick, that is how I will verify before I get to move on.
Okay.
Can that work?
Okay, so I guess you asking the question tells me that I can go. All right, so I was going to stop you to say to you that be careful, because you have just really one real example that we're looking at. I think this is the second example we're going through, second question we're going through, but so you can't make a conjecture based on just one example. You have to see multiple examples before you can come up with something definitive as you would have come with. You redeemed yourself, however, in the last part of the conversation to say something like this can be used to verify if your calculation is correct. And I would say yes. I would want you to use this as a verification, because it does not always happen. The pattern is not always readily seen. It depends on the function that you're given, right? But there is a pattern here that I thought you were going to talk to me about. I won't tell you the pattern because I'm teaching you, but like when you know on learning differentiation, I'm teaching you how to identify some stuff. So at some point in time, you can look at it. I'm looking at the pattern right about now. And you can see the pattern, and then you can talk to me about that pattern at any other time. Right? You don't have to. We don't have. Matter of fact, I'm not even going to.
You mean that the first part of it is always something that is 0.
The pattern I'm talking about is in blue. matter of fact, I think I should put this over here. I think this is deserving to be right here. So
1, 2,
Sir,
6.
You see it? What
Another
is it?
added denominator I'm talk.
No.
Is it? Yes.
Yeah,
yes,
me see the pattern, man.
2, 3, 4. Me see it.
I did. Now that I mentioned, sir.
Okay,
No,
fine.
I mentioned that. I mentioned
that,
that the denominator, the power them for the denominators
yeah, I
are
didn't
going to
want
count up.
yeah, but that's not the only pattern that is there. So yes, so you see that this is x plus 1 to the second, x plus 1 to the third, to the fourth, to the fifth, to the sixth. What other pattern can you pick up from it? Everton spoke about one other, but there's another.
Oh, sir, like you have the first one would be
positive, negative. I know, we didn't talk about that.
And he spoke about, that's the second one he spoke about, but there is a final one.
Final one.
Are they differentiations here?
Oh,
no one there.
Look at the first one to see how I got the numerator in the second one. Look at the second one to see how I got the numerator in the third one. And according to this the first. So look at this one to see how I get this -2 right here. Yeah. Look at this one to see how I get the 6 right here. Look at this one to see how I get the 24 right here, the -24 here, and so forth and so on. Can you pick up that pattern?
-24. Negative sign. Negative, positive. No. Hold on. Differentiate that, they cancel this so that they have end up with they have 4. They cancel out that, they end up with 3.
Sir, is it the
that times that is
number, which is the numerator, times the power of the denominator to get the other answer?
Okay, all right, so good.
Come again?
So this one times this 2 will give me this 2, but remember you have to alternate the signs, so that's what becomes -2. This -2 times this 3 gives a -6, but you alternate the signs, so it becomes a +6. This 6 times this 4 gives 24, but you have to alternate the signs, so it becomes -24. -24 times 5 is a -120, but you have to alternate the signs, so you get a +120. All right?
Yo!
So
it just done. It just done.
So I'm saying to you, but as I said to you,
use it as a verification. Yes, sir.
Use it as a verification. It does not always work in this case because it depends upon the function that you're working with. So what I'm saying to you, what's the point I'm making? The point I'm making is, what if the question had now asked us to go up to x to the 8th? I would say to you, having seen the pattern, I wouldn't ask you to go and do the differentiation over here. So again, you can write on to the 5th power. What would the 5th power be? Tell me what the fifth differentiation would be.
That would be 120 times
-720, sir.
Very good, Shanice. It will be -720 over x plus 1 to the 7th. You see that?
See it? Yeah, man. You don't see here the bright people and the spit out the answer.
So very good, Shans. So what I'm saying to you is, when you're doing your macarons, you can, once it is that you can identify the pattern. So you have identified the pattern from here to here, from here to here, from here to here to here. You say, okay, but this pattern works because this times this you alternate the signs, you get this. This times this you alternate the signs, you get -24. And you say that this is positive, negative, positive, negative, positive. That means the other one has to be negative. 120 times 6 is 720. 720 over x plus 1 to the 7th. So if I ask you the question, I won't necessarily go and work out the x to the 5th because me can go and do that myself down here, so because me see the pattern. And then we can work, once we write down the 5th one, we can write down the 6th one, we can write down the 7th. So I can write down as many of them as possible because I would have seen the pattern. Math is a study of pattern. We study smart and not hard. So, but nonetheless, I had to go through with the differentiations here to show you what is happening here.
Sir, so it's a safe bet to say when I'm going to the exam, the first thing I'm going to do, I do the first one and then complete the table here and then continue working and make sure everything line up and then we just move on.
Not just the first one, you have to do a series of them. So you can't just, remember I said to you earlier, you can't just do one example and make a conjecture.
Oh, okay.
So you have to do, I did 1, I did 2, I did 3, and when I moved to the 4th, no, this is not, I didn't do that. They gave me that. One, when I did this one, and I look at the answer, I can say, okay, but all right, let me try the other one. And I can possibly write down this third one here as my possible answer. When I do the differentiation, if when I do the differentiation, I get it. I said, okay, fine. Let me write down this one. And then I write down that one. And then I do the differentiation and get that one. I don't necessarily do this one. I just going to use the rule that I have to write down this one. But I'm just saying this to say to you that you know, it is what it is. You know, you guys are studying computers. And the algorithm, once it is written, that is the algorithm. So and that algorithm goes to that particular you know.
And computer is built on top of math. So
right. So if you change the algorithm, it's a different function you're going to get. So if the algorithm is 1 0 1 0 1 0 1, but you change the algorithm now to be 1 0 1 0 1 0 1, and then you put a 0 there, you can't expect the computer to operate in the initial stage, which was 1 0 1 0 1. Now that you have a 0 to it, it is going to change the algorithm. Right? Go ahead.
No, man, all right, sir.
Good. Fair enough. All right. So I'm happy that you're seeing this because I'm going to give you Jesus 11 o'clock. I'm going to give you one more to the bottom. Let us finish off this question. So the question says this. So now that we have or f of 0, or f of 0 is 1. So say f of 0, I put it as 1. F dash of 0 is negative 2. So that's why I have the negative 2x. See, that's why I have the negative 2 because f dash of 0 is negative 2. So I put negative 2 and this x comes back right here. F dash of 0 over 2 factorial. Sorry, f double dash of 0 over 2 factorial. It's going to be 6 over 2 factorial. But 2 factorial is going to be 2. So it's going to be 6 over 2 factorial, which is going to be 3. So that's why I got the 3 here.
Oh.
Sorry, I'm going to put in another line so that when you're revising, you can see. But let me just finish my thought. And then f, and then I put my x squared, of course. F triple dash of 0 is negative 24. So it's going to be negative 24 over 3 factorial. But 3 factorial is 6. So it's negative 24 divided by 6. You're going to get negative 4. And of course, this is the x cubed. And then now we'll go up to our 5th factorial. So this is, if this is 4, that means that this one is 4 factorial. Because remember, you know, this is squared, the second derivative. This is the third derivative, x cubed. This is the nth derivative, x to the n. So now that I'm in f to the 4th, I know that I'm going to divide this by 4 factorial. 4 factorial is 4 times 3 is 12. 12 times 2 is 24. So it's going to be 120 divided by 24. It's going to be equal to 5. All right? So allow me then to write this other step so that you can see what is happening. F is 1. F factorial is 1. The other one is negative 2. And the second one is what now? The second one is 6. The third one is 24. Negative 24. And then the other one is positive 120.
Sir, how much pages in total is the notes that you already have?
I don't know. What I've done is to over 4 factorial. What I've done is just to do the stuff. Yeah, and not only that. I mean, so the basic set of information is contained in the notes itself. I don't have to put this in parentheses. So as I go along from class to class, based on the explanation that I need to give, I'll update the notes. All right, so this one has 35 pages, and I may have another document that may have 40 pages. I know the section on, let me just tell you which one. The section on
print, I plan to print out this and staple it and walk with it like one Bible.
The section that I have on multivariable functions. Multivariable calculus, the last section, as a matter of fact. There are 4 units to this story, and I'm trying to finish off unit 1. So I have 3 units to go through, but let us not even worry about that. The multivariable function I know has it's a largest document because it has about 11 or 12 or 14 different areas. So you can do it unit by unit, as I've been sending the document, so you can just click these units together and just keep. That's a part of my plan at some point in time. When I have some time, what I plan to do is, so this document has 39 pages, but of the 39 pages, by the time I get to this document, it may reach about 45 because I'll add more questions to it. So my plan of action is at some point in time, I will just create a document and create a manual for the calculus too. So once it is that you're doing the course, you have access to the manual where it is that
sir,
you have.
Sir, that's the people after we, sir.
Yeah.
I go print that. I go print it.
I mean, it is a given. All right, look at this. So I've just included this new line in here so that you don't have to jump directly from here to here. So I just put in this line right here to show you now that my f of 0, I'm making a substitution. My f of 0 is here. My f dash of 0 is this -2. Yeah. My f double dash of 0 is a 6. F triple dash of 0 is a -24. And the f to the 4th dash of x is going to be 120 over 4 factorial.
Okay.
All right. And then when you evaluate all of that, you can get this. Now that I have...
Sir,
go ahead.
So you have 5x to the 5th. It should be x to the 4th.
Just a check if you look, man.
Thank you.
Just a check if you look.
And that is it, to make sure that you're paying attention. So very good. Very, very, very good that you're paying attention. Nice job. Nice job. All right. So this one says that's the end of the document. But it's not the end of it for me, because having gone through that, I need to give you this one to do for me. Jesus, I feel like I'm sitting on forever. Guys, I'm going to give you an opportunity to get up and walk here. It's not good for you to be seated so long, DDT or MINE. All right. This is a past paper question, and I want to go through this with you. But guess what? I'm not spending more than 20 minutes. All right, I'm not spending more than half an hour. I'll give about 10 minutes to work yourself through this, and then I'll come up for about 20 minutes. I'm going to use the last half an hour of the class to move into unit 2. I must. So do me a favor. I'm going to ask that you just walk around for about a minute or two, and then come back and attack this one. I have the solution to the question already. Yeah, just improve on your sedentary lifestyle. Ouch. Walk around a minute or two, and then come back and try this one for me. This one is not difficult. It's just that you are going to have, matter of fact, should I give you, let me give you an thing. I want you to go up to x to the 5th in this one, right? Go up to x to the 5th, and I'll tell, yeah, I'm just giving you a little guide right here. Go up to x to the 5th for this one. So walk around 2 minutes, come back, I'll give you another 8 minutes to do this. 1.
Sir. Sir. Hello. You there? Yo, guys, I'm asking you something. Is ln bracket 1 plus 2x over ln1 bracket plus 2x, correct?
Me, I have 1 over.
No, the question me I ask you. Because it say x, so it's a over x. So that means x is still ln1 plus 2x.
Yeah.
All right, cool.
So you're gonna do the first one and then do the second one?
What do you mean by the first one and then?
Like the f of x ln plus ln bracket 1 plus 2x bracket, and and hence determine the function. So you're gonna do the first one, then do the second one. No.
Yeah, for the first one, got the first one and the series where use the derivative them to the fifth derivative.
But do that to the fifth or fourth, him say.
And to the fifth. Him say go to the fifth. So
for the first one, what you get for the first one?
No, me just start it. Me did my way to work. Me just wait.
Oh.
Yeah.
What you get for your first one?
We are talking.
Me get to find the ln. You have to find the ln sitting off a start first. So come me get the 2x over 1 plus 2x. So now the first
ln I'll put it over 1, right? Put 1 over it. So you end up with 1 plus 2x. Cool. Yes, times the
for the first derivative.
So that's going to be, we just write now 2 over 1 plus 2x from the first derivative.
Times 2.
But work it out. So you times the 1 and the 2, so you're going to have 2 over 1 plus 2x. I still the same thing.
Why I still the same thing? 2 1s 2, 2 4 4x. 2 1s 2 times 2, that are 4x, so it's 2 plus 4x, right?
No.
I want me do. I want me there, brother. Yo, man, not fire today at all, brother.
For the first derivative, when I have 1 over 1 plus 2x times 2.
Yeah.
Then I have to work out that.
Yeah.
Where you say again?
Yeah, for the first derivative, when you start differentiate, then you put 1 over 1 plus 2x times 2. Yeah. And you work out that. So that's gonna be 2 over 1 plus 2x. I don't know. That right?
The 1 plus 2x square. I'm say when you do that, you have to square the denominator.
Oh yeah, shit.
What?
So it's gonna be 2 over 1 plus 2x to this 2. No. I don't know.
So it's a 2.
Kim?
Yo.
The answer we have is right. 2 over 1 plus 2x. That is the first derivative.
Right, and then then you're gonna use that for your second derivative. So
yeah. But no square, no depend that bracket. For
the first one, no. For the first one, no. But I get the mix up that. So we have the f with the 1. So
wanna work out f of x already?
F of x would be the 2 over the 1 plus 2x. And then
ln 1 hour.
All right, the ln, which would be the first.
ln are gonna be 1 over 1 plus 2x. That's how the ln
be 2x.
Times 2. Times 2.
So number 2 over 1 plus 2x. Then the other one,
first thing. Yeah.
Yeah, then the other one, you don't get 2 plus 2 plus 2 over 1 plus 2x squared. And then the other one, no.
Remember, you know, when they say when you do this, you don't mess with the denominator. Or that thing they say?
Yeah, you know, for trouble the denominator from it.
All right. So that. All right. So after we get, what the next step after you do that? You do is that then you gotta equate that to 0. No.
Yeah, the answer them when you get you substitute 0 with
Very
x.
good. Very good.
And
Stop. Thank you for correcting him, please. It's not equating it to 0, but you're substituting
All right.
0.
Sorry. All right.
Continue.
X in the value you put it.
This man here there listen to her and wouldn't say a word to Ratty. You're afraid of that man, you know? Afraid of that man.
Oh, you love me alone, you know, right? Let me tell you something. Guys, and I want you to appreciate this of me. It's when I mute, I don't mute to go back to sleep. I want to give you a sort of independence, and this is how we learn. So that's why I'm where I'm at. So continue working. Remember, you just have a few more minutes now because 11:30 I'm going to start a new topic. So continue. How far? You finish your question right now?
You really never there for true.
Okay, not true.
Now I start boycott the people them working, you know. I start make some of them tickets boil up. Cause you are going. Can't afford to feel this again, bro. Yo, anybody have like time in the week, like them would have work and maybe get all an hour and a half free or something. Go sit down and beat some of them questions.
And let me tell you, let me put myself under additional pressure. Is if I like let me just check it before I speak out of turn. Let's go now. All right. Is it like for this coming week now? This coming week, if you guys say boy wanna have a 1 hour upon a Wednesday or a 2 hour upon a Wednesday in the day because you know I have evening class and things. I could arrange my time for this week, because next week, the week after, it's going to be a rough one. But for this coming week, if you have a 1 hour lunchtime, we could have joined from a lunch hour break and I would just run a 1 person in a lunch hour break. So I arrange it. I am doing this because I want you guys to pass. So think about it. All right, me hear that word there, so I know it mean. All right.
So I think it mute.
Sir,
answer them. I look
Sir, me personally right now, you know, pressure bus pipe, you know, sir. I'm in a really business right now, you know, so they might have to cost me about some ticket, you know, for next week. You know, I'll call for cost me, you know. Tell them to me light gone or something, you know, sir. Right now, my corner dark, you know. My corner dark. Last week me a fire and this week me just feel like me now want old and can't come out.
Come, let's go.
I did the work in a week. Imagine me never do none.
Lord Jesus, I'm giving God thanks that you did. All right, let's go. I heard you, Kimmy. Very nice. Again, proving that you're following what is happening. The differentiation here is slightly different from the one that we did before. Remember,
but no, it never was the same. It was not the same thing.
Good. Okay. I'm happy that you recognize that. All right. All
right. That. Well, on sir, stop moving. No, sir, I try look on it. That, and then equate it to 0. No, sorry, you substitute 0. Sorry. All right, and then you say substitute 0 there. Anyway, you have x substitute 0 in another function. So that does end up to be 1. Right. They differentiate. Differentiate it again. Or you equate it to that. Just get a little pattern, sir.
Oh yeah, may have that. Yes, I did right.
I can just catch a little pattern, sir. So that me never wrong go down to the third then, cause I read 16 and I stop in me. I said, Jesus and peace. This wrong, you know. This wrong. I mean, should I do the table? Should I do the, if you do the table in a mood and say that wrong, you know?
Let's go.
Yeah,
So you're given a function.
Yes, sir.
F of x is equal to ln 1.
Sorry, I can send this as you've done this topic before you go to the next topic. Just send the document here, sir.
Okay.
What the name of the document here, sir? Unit 1 what?
Unit 1, applications of differentiation.
All right.
All right, so that's a given function. And we're differentiating this function. And remember, Maclaurin talks about differentiation.
Yeah.
So let's go. So differential of the ln function, differential of ln x, 1 over x.
Plus
1
time
over x.
Then the differentiation of the denominator.
No, not the denominator. Well, okay, fine, the denominator. All right, fair enough. I see where he's going there. But say the differential of the function.
Okay.
All right. So it's going to be 1 over 1 plus 2x, and then differentiating the 1 plus 2x, you can get 2.
And then you plug in the elements out of the function, out of the Maclaurins.
So plug in the 0 after having differentiated, because this is the differential of that, which is this. Then I'm going to plug in the 0 now. So that goes to 0. So we have 2 over 1, which is 2.
2 over 1. This is 2. Yeah.
When I differentiate this one now, this is what I'm going to differentiate now. So this so you notice now that it no longer becomes an ln function, but it becomes a quotient question now.
Yeah, sir, at that I realize, sir, I look back on the quotient and I say, all right. So that's why I'm reaching on where it says 16 over, and I say 16, that look wrong, stop.
So this is a point I'm making now. So you can't just say that you know the product rule, but you don't know the quotient rule, because you don't know which rules the question will think it says.
Them got jump push out.
Very good. So let's go. The denominator, 1 plus 2x, see it yourself, 1 plus 2x, times the differentiation of the numerator, which is 0.
Yeah, what is 0? So the
minus the numerator, right? Minus the numerator, which is minus this 2, times the differentiation of the denominator, which is a 2.
It's supposed to get -4.
-4 over the denominator here. You recognize that we recognize in this case, we couldn't cancel any of the powers for this particular part of the question. We don't have no power to cancel out right here. So we can move on now.
Sir, you know, long me there, so I wonder, I'm put it there, sir. That means me wrong from up here, so then.
Right, because this 1 minus 2x is multiplied by 0, so that cancels out. Right, that cancels out.
4.
And then now, let me just do this one since right here. We're finding f of 0, f double dash of 0, sorry. And f double dash of 0. F double dash of 0 is going to be anywhere in the function I see x, I put 0. So 2 times 0 is 0. 1 plus 0 squares is 1. So this becomes -4. That becomes -4. And then I'm going to differentiate this to get the third derivative. So when I differentiate this, it's a denominator. So I'm going to write back the 1 plus 2x squared, see yourself, 1 plus 2x squared, times the differentiation of the numerator, which is 0, minus the numerator, minus the numerator. Here's a negative, so it's going to be a minus times a -4, times the differentiation of the denominator. When I'm differentiating the denominator, I'm going to get this 2 to come in front of here. See it right here, so? Times 1 plus 2x to the first power, see it here? Times the differentiation now of the inside, which is going to be 2. What I'm going to say to you, be careful, because the one that we did before, it was 1 plus x, or x plus 1, same difference. So those students who normally forget that they have to find the derivative of the inside would have gotten away with the first example we looked at, because the differential of the inside was 1. So if you never remember to differentiate the inside of the function, you'll end up getting the question right nonetheless. But if you move on to a second question now, where you keep forgetting to differentiate the inside of the parentheses, you will get this question wrong, because the differential of the inside here now is not 1 but 2. So you have to remember. So even though, and you notice, even though the differential in here is 1 and I know it was 1, I still, watch me, because I have to bring across this point. I still wrote, no, I'm going the other way. I still wrote times 1, times 1, times 1, times 1, because I want to get into your cranium. That not because the differential of in here is 1, I'm going to leave it out so that when it becomes greater than 1, you don't know what to do because anybody. I was consistent in putting the times 1 to show that you have to differentiate on the inside. Now that the coefficient of this one is greater than 1, see here it comes into play, times 2, times 2, times 2, times 2. So you have to be very consistent. Okay, let's go. So it's a denominator. Oh, we did that already. So times is 2. And then now all of this goes to 0. This -1 times this -4 is +4. 4 times 2 is 8. And 8 times 2 is 16. So I'm going to have 16. Oh, this x plus this 1 plus 2x, sir, will be cancelled by one of the x, 1 plus 2x to the 4th. So I'm going to leave 3. So I'm going to have 16 over 1 plus 2x to the 3rd, which becomes my third derivative.
Sir, the first 2 bowl me for 6. But now I like to you, sir, because I was so unsure how I get the answer I get, and then I just lost. My model threw it to a point, sir, but then I just give up. I say, no, man, this can't right.
No problem, man. Just you have to stick with it. You have to stick with it. Newton-Raphson is a staple on the exam. Mean take income is a staple. Maclaren's is a staple on the exam. Means it can come.
So I need to know all of my quotient,
and chain
rule, know all of them there. I know
plus
to incorporate them.
Plus the exponential function and the logarithmic function. Yes, sir. You have to. Let's go. So I'm differentiating this one now. So it's a denominator. 1 plus 2x to the 3rd. 1 plus 2x to the 3rd. Times the differentiation of the numerator. It's a constant. So it equals to 0. Minus the numerator, minus 16. Times the differentiation of the denominator. So when I differentiate in the denominator, it becomes 3. Bam. Times 1 plus 2x to the 2nd. See here? 3 times 1 plus 2x to the 2nd power. Times the differentiation of the inside, which is going to be 2. It's the 2 right here. So, right? All over the denominator squares. Oh, sorry, you said the square, so that can multiply by 12. We get 6, sir. That's why I have a 6 here. Negative 16 times 3 is now 48. Negative 48. And negative 48 times 2 is negative 96. See right here, sir? But sir, you didn't leave off the 1 plus 2x to the 2nd power. Not really. Because what I did with the 1 plus 2x to the 2nd power was to divide it through by this one here to get and reduce it by 4. And reduce it by 4. Hold on. All right, so look at the rest of that question and tell me if you see what is happening. Hey, Momo, so. Hello?
You know what? I'm going to start write it out in my book exactly like how sir have it on the page. Because always I get mixed up.
Why? I don't know. I think excess. I don't recognize that it's
Think you got quit exit?
It is a Saturday. It's the second call from them. Anyway, let's go. So this is right. So I did not forget this. I'm canceling this 1 plus 2x squared.
No, you said that. You said that.
Right. And I'm going to left with the 4th. And then now here, I'm going to substitute 96. 0. So it's going to be negative 96. And then the final one that I will do is differentiating here again, the denominator. right here,
denominator
times the differentiation of the numerator,
constant,
0, minus the numerator. Remember,
turn
the
this into
numerator is a
positive,
negative. Right.
turn
It's
it
going to be
into
2 negative.
positive.
And then times the differentiation. So this is the part that I'm worried about with you guys. Differentiating this one. So it's going to be 4, bam, times 1 plus 2x to the third, times the differentiation of the inside here, which is 2.
Wow, come again.
This 4
yeah,
is going to be multiplied in front of here, which is this 4 right here. So
yeah, man.
1 minus 2x to the third, which is 1 minus 2x to the third right here. So, and then
But that's different from when you do up at top of it.
I know, but that's what I said to you. I never said different enough. I said this is what I'm worried about you guys.
Okay.
So I'm worried that you're not remembering how to do the differentiation. That's why I said what I said. Let's go. So all of this goes to 0. So negative 1 times 96 is positive 96. Positive 96 times 4 times 2 is 768.
Yeah.
This 120, this 1 plus 2x to the third is going to be
cancelled. So
go
down to 5.
So we're going to go down to 5. And then I'm stopping there. All right. I'm stopping there. Now, and then I'm going to have this was just a while ago. I scroll back up to the question because I want to make sure that I'm doing what the question is asking of me. And it's one of the things that I recognize with students. Them ask about one thing, and because they want something funny to write the question, and you don't even know the question I ask you, and what you write makes sense, but you're not answering the question. It's a different question you're answering. And,
sir, we need to memorize the Maclaurin's thing there.
Yeah, man. All right, so that's why I just went back and just copied the formula right here. Okay, so let's go. We are doing good. I'm 3 minutes over my time that I wanted to for 11:30. My f of 0 is 0. Yeah. My f dash of 0 is 2. I'm just doing the substitution here. My f double dash of 0 is going to be negative 4. So it's going to be negative 4 over 2 factorial, which is this.
So why you have a positive 4 there, sir?
The negative 4 is right here. So the negative comes right here.
Oh, okay. Sorry, my bad. Continue.
And then now the f triple dash is going to be 16. So it's going to be plus 16 over 3 factorial.
Okay. And
then the f to the fourth is going to be 96. So the negative sign is right here. So 96 over 4 factorial. And this is positive 768. So it becomes plus 768 over 5 factorial. Right? And then and I'm putting my plus dot because it continues. And then I'm just evaluating. This 0 is just okay. That's my question. That's my question. That's the end of the question right here. Right? That's a Maclaurin's. Now it says, and hence determine this over x. So what it is that I want you to determine now is ln1 plus 2x divided by x. The question gave us f of x to be equal to ln1 plus 2x. It is asking us hence. Once you see this word hence, that word hence means you have to use the information from before to answer the question that comes thereafter. If the question had said hence or otherwise, then you could use another method. But the mere fact that the question says hence, it follows that you have to use the question, the information from before, to answer the other parts of the question going forward. All right? So,
so I want 20 marks this.
Maybe not as many as 20. It could be about 12 marks.
What 12 marks for what, sir?
How much work?
Sir, we are talking about, sir.
It's about 12 marks.
I couldn't want to see me left exec then.
The last exam, the question on this I think was like about 14 marks, 7 marks for the first part, 7 marks for the second part. Yeah, not 20, definitely. All right, let's go. So it says here that we need to hence determine that. So since we have what f of x would work out to be here, all of that, I can leave with the 0. All of that. All I need to do is just divide all of that by x. So all I'm going to be doing here is dividing all of these. All right, I'm feeling lazy. What do? I do.
About a lazy, you know. Don't miss a step. Don't skip and say a big school, or infant school, or they will need every step.
That's what we can see like that. So it means that because they ask us to find ln1 plus 2x over x, all of this is going to represent ln1. So this is all of that divided by x. So is this term divided by x, it is 2x divided by x, which is just going to be. All right, hold on. All right, so let me finish off this question. We're not quite finished with this part yet. Wow. Forgive me. Forgive me. Part 1 is not quite finished. So copy. I missed something a while ago. Part 1 is not quite finished because I didn't divide it through by the factorial. Remember, we have to divide it by the factorial. The factorial is going to be. The factorial is going to be 2 factorial is 2. So this is going to be 4 over 2, which is 2.
What the factorial sound like? Oh.
4 factorial is 2, don't? 2, sorry, 4 divided by 2 factorial is going to be 2, right?
Yeah. Yes, sir.
It's going to be 2x squared. 3 factorial is how much? 6?
3.
3 factorial is 6.
Yes, sir.
So that's going to be 8 over 3 then. And 4 factorial is what? 24?
Yes, sir.
Yeah, 24.
And 5 factorial is
120. 120. 5 factorial are 120.
So that's 32 over 5.
32 over 5. Thank you. All right. So look at what I have now. Look and tell me if you agree with that.
Yes, sir.
All right. Good job. Nice. And then now, this is what I should have. Copy. That's what I should have divided by all of that over x. All of that divided by x.
So make sure I get a whole heap of sleep on a Friday night before I come to that class.
See, is all of is what is happening here? So all of this, because remember the question says determine ln1 plus 2x, which is the same thing as we have here.
Yeah.
Over x. So I now need to divide that by x. So all of those now will be divided by x. So I'm going to end up with this divided by x is going to give me 2 minus 2x plus 8 over 3 x squared minus 4x to the third plus 32 over that x to the fourth, don't it?
Yes, sir.
All right, good. And that's my
Sir, wait, whoa, sir. You're dealing with the bright people, sir. Hold on. What go on a while ago? Go back through that division there where you do a while ago. 2x.
And to the second power, and then I'm going to have this to the first power. And I'm going to like that. And then this one is going to be losing its x. And then that is going to be having that. And then down.
Good thing, sir. Nothing for do on a Saturday afternoon, you know. You can go and teach.
All right. So this is what is happening here now. So what I'm saying to you, we have our f of x to be this. But let me refer to the question. The question says to determine ln 1 plus 2x over x.
Hence.
So it means, once I say hence, it means that we have to use the information from before to work this other part of the question. So that's my hence. My hence is going to be, having worked, I didn't evaluate this. Forgive me, I thought I had done it. So having evaluated this piece down here, the hence part, which is the part 2 of the question now, I'm dividing that by x. So each term is going to be divided by x, and that will give me my answer. Now 2x over x is going to be 2x minus 2x squared. I'm just losing one of the x's. So this is going to be minus 2x right here. So 8 over 3x squared right here. So minus 4x cubed right here. So plus 32x to the 4th right here. So,
okay. All right. No, you make sense, sir.
And that's the end of that. All right. That's the end of this. I am 30 minutes late, but I have to move on. Everton, I can't send this now because I'm not going to stop. I have to go through.
Yeah, man, do you think, sir?
The Lord, should I do? No, I can't do that because I have to do the integration first. Because the first order differential includes integration, so I have to do integration. And the multivariable calculus also includes integration. So my next topic has to be integration. All right.
Hey,
sir.
I have a level of ratings for you today, sir.
Thanks, well.
Your brain big, sir. All right, I know.
Don't worry about it, man. It's years of studying and all right, let's go. Stop share. I'm going to stop share that document. The aim for this one is just really an introduction. So if you see me go through this quickly, it's just to introduce it to whet your appetite, right? To whet your appetite. Now, what I have done as a good teacher is to give you the rules of integration. What I've done is to give you the rules of integration. I'm going to go through the rules of integration with you, and then I would do a little basic recall because I know you'd have done this in first semester, in Calculus 1, and I will go through some. So this is what I intend to do in class today, is to go through these simple integration questions with you, and then this is where the Calculus 2 will start. Mean value theorem for differentiation, and we're going to go through some stuff, and that's where the big stuff starts. So let us see if we can even do the introduction part. That come next week, all being well, we can move on.
People dead.
So hold on there now. All right, let's go. On the mark, get set and go. So it says the following rules for indefinite integrals are obtained by reversing the corresponding rules for differentiation. What does that mean? The opposite of differentiation is integration. So having done the differentiation, is it like what we just did a while ago? Ln 1 plus x over x. If we want to get back our ln 1 plus x, what we do? We have to go integrate it because we would have done the differentiation. Then in order to get the stuff now, we're going to do the antiderivative. We're going to do the antiderivative. And the antiderivative is really just an integration, which is opposite to differentiation, right? Or the reverse, all right? So it says that accuracy is easily checked by taking the derivative of the antiderivative to be sure that it equals to the integrand. The antiderivative is just really the integration that we're doing. And the opposite to differentiation is integration, all right? The rules are illustrated below. These are indefinite because they don't have an upper limit or a lower limit.
Yeah.
So once you don't have limits, an upper limit or a lower limit, then it is that we talk about our indefinite integrals. If we have a limit, we'll speak about our definite integrals. All right, so let's go. Rule 1. The integral of a constant k, is k dx. Now when I integrate a constant, that constant is going to pick up an x. So when I integrate the constant k, I'm going to get kx plus c. Now, if you look here, let me just kill that bird right now. This one has a plus c, rule 1. Rule 2 has a plus c. Rule 3 has a plus c in this one or this one. Rule 4 has a plus c. Rule 5 has a plus c. Rule 6 has Rule 6 now has a plus c. Rule 7.
Somebody never eat the stew peas. Bring up and cuff when they do this.
Has a plus c, and this one also has a plus c. So all the rules, all the indefinite integrals will have your constant of integration. Your plus c is known as your constant of integration.
So it's only indefinite.
Only indefinite has a plus c.
Sorry, only indefinite do I do for this course?
No, you need the definite ones too. Right? So so they all have plus c's. All have plus c's. All right? So let's go there. So the integral of a constant k is going to be kx plus c. So what is the integral of 5, for example? The integral of 5 is going to be 5x plus c. When you differentiate 5x, you're going to get 5. So you get back your 5 that you start off with, don't it?
Yeah.
So remember, the integral of a constant is going to be kx plus c. The integral of 1, written as dx, you know, not 1 dx. We don't write it as 1 dx, it's just written as dx, is x plus c. So when I integrate dx, not 1 dx, but just dx, I'm going to get x plus c. All right? And this is revision. So I don't need to go through because I know those who I taught calculus 1 in this class know I would have done this with you. And I'm sure your other calculus 1 lecturer would have.
Sir, I'm never there, sir.
You know,
that was over a year ago.
So you know much information drop down in my brain and run through that and gone and take up them spaces, sir. Just like when your phone run out of memory and it stop take picture and stop function properly, you have to delete the picture then before it work again.
It again.
You can continue, sir.
You see, when you are doing this calculus 1, you were face to face.
Yes, sir, but not like a year ago.
I don't care. You're face to face, and that special person was in the class. All right, let's move on. Don't say nothing, Peter again.
Which special person you talking?
You can scroll up to for a second.
Oh, goodness.
Anyone say special. I wonder who them carry got Bellevue, because special people got Bellevue, you know.
Peter Gay, come here, Peter Gay. Me know. Romain, you see it now, Papa? You asked me to scroll up. You all right now?
Yeah, man. Me just see one right on the title.
Okay, yeah, man. All right, so let's go now. So when we integrate in the integral of the power function x to the n is not -1. It's very important that n is not -1, and I'll show you why n is not -1. So the integration of x to the n, you're adding 1 to the power and divide by the new power plus c. And this rule here is something that you can use more often than any other of the rules. So I'm going to highlight it.
A hint for exam.
Yeah, but a hint for everything else to do. So like when we're doing the differentiation, y equals x to the n, and you have n x to the n plus 1. You're adding 1 to the power. You subtract 1 from the power rather. Y equals x to the n. So when you differentiate, you can have n x to the n minus 1. You subtract 1 from the power. In integration, you're going to add 1 to the power. Because remember, it's the opposite, you know. So the opposite of addition is subtraction. So we have to add 1 to the power, but this one goes a step further. We're dividing by the new power.
Ooh.
Anybody feel that?
Sir, none of what you say a while ago never make no sense until you say you increment the power.
You know,
so with differentiation, it increment down, and with integration it up. All right.
So it goes up, but guess what? We're dividing by the new power. So
we have to divide it again?
You have to divide it by the new power. Yeah, man. It's not difficult. When I tell you it's not difficult, trust me, it's not difficult.
All right, but kind of remember something like that, sir.
Yeah, man. So x to the n, you're adding 1 to the power, so it becomes x to the n plus 1, and you're dividing by the new power, which is going to be over n plus 1. See, let me write it another way. I wrote it 2 ways. X to the n plus 1 over n plus 1. So you're adding 1 to the power. So you have x to the n. Sorry, I didn't have my stuff, so you're not seeing what I'm pointing at. So you have x to the n right here. Now that you have your x to the n, I'm adding 1 to the power x to the n plus 1. See it over yourself? And then I'm dividing by this new power n plus 1. So I'm adding 1 to the power.
So that's why the n plus 1 there at the bottom. This on.
Very good.
So you divide the entire thing by n plus 1?
The entire thing by n plus 1. The entire thing by n plus 1. So what I just did about is color coded. The same n plus 1. Whatever is in the power up there, so is what we're going to divide the entire thing by. X to the n is going to be equal to x to the n plus 1 divided by n plus 1. All right, I'm not going to spend much more time on that because we're going to do the examples. Then it says the integral of x to the minus 1. X to the minus 1 from indices is the same thing as 1 over x. We just did this. And when we're integrating 1 over x, when x is -1, we get the ln x function. So when x is equal to -1, x must be equal to -1 alone. So if it equals to -2, we use the same thing? No. Only -1. Only -1. So when x is equal to -1, that's the time we have the natural logarithm function, the ln x function. So when we're integrating x to the -1, only because, remember, I told you about some exceptions earlier. Here goes one of the exceptions. Only when x is -1 that we end up getting an ln function in our answer. If x is any number other than -1 in its power, will not yield the ln function. The ln function is only specific to when it is raised to the -1st power. Let's go. So now, and x is greater than 0, right? So you can have your ln x plus c. The condition x greater than 0 is added because only positive numbers have logarithms. Only positive numbers have logarithms. Only positive numbers. So you can't take the logarithm of a negative number. That's what it is saying. And you would learn this from a long time, right? So for negative numbers, we have to use the absolute value. Them stroke it inside of the stuff. So we just use the absolute value. Now this is important for when I catch differential equations, right? So you can't take the logarithm of a negative number. So if it so happens that you're integrating and you end up with a negative number there, you have to find the absolute value. What does the absolute value say, sir? The absolute value of -2 is +2. The absolute value of -7 is +7. You can't have a negative absolute value. Absolute values will always be positive. All right? Then rule 5 says the integral of a natural exponential function. Blow, sir. Sir, you just did the integral of e to the x. All right. The integral of e to the x, as I told you last class, is also e to the x. The integral of e to the x is theta. E to the kx is e to the kx. But what it is that you have to do, when we're differentiating the exponential function, we say that the differential of e to the x is e to the x times the differential of the power. This one is the same thing with one more inclusion. The integration of the exponential function is going to be the integral of e to the x is e to the x. You are going to differentiate the power and reciprocate it. Put 1 over the differential. So it's going to be 1 over the differential of kx. All right? So if it was a differentiation, you'd just have k e to the kx. You know this. If it was a differentiation, you have k e to the kx, right? And the k will be multiplied by the stuff. So in the handout that we did earlier, I spoke to you, and let me just bring it back because I want you to see the correlation between the two, to prove to you again that stop share, new share, watch it. So we can clearly see that the answer is going to be the differentiation, is the differentiated power times the given exponential function, right? Now, the opposite of multiplication is division. So instead of this times here, for the integration we can have divided by, and that's why we have the 1 over x. That's why we have this 1 over k, sorry, not x, but k. That's why we have 1 over k. So if you and that's one of the things that I use when I was studying, and I hope that you use it too whilst you're studying. With the differentiation first, differentiation is etched into your headspace. Know the rules of differentiation, and they are finite, meaning that you can count them. Integration, you have an infinite set of different integration. Integration, you have different methods and this and that and rate and it just woolly, right? But if you can remember your differentiation, the correlation to the integration will be seamless. So in this case, when you're integrating the exponential function, the integration of the exponential function is the exponential function itself times by the reciprocated differential. So you can differentiate the power and then put 1 over it. So it becomes 1 over k. All right, good. And then rule 6 says the integral of a constant times a function equals the constant times the antiderivative or the integral of the function. All right, what it's saying that I have k f of x dx, because this is a constant k, we can haul it out. See it so? We take it out. Because it's a constant, I can remove it and only differentiate rubbishness and only integrate the f of x dx. See here, f of x dx. Oh, now I understand why I had it. This plus c shouldn't be there. I'm only showing you that plus c shouldn't be there because I'm actually not doing a differential here. I'm not doing a differential right there. I'm doing a different. Sorry, why am I talking about differential? I'm not doing an integral here. I'm only rewriting it here, so that shouldn't be there, and this shouldn't be here because I'm only rewriting. I'm only rewriting the function here in a different form, and I'm only rewriting it here. So I've not done the integration right here. So that's why I never put it before. I was wondering how I would make such a big mistake. Let me just check. Here I would integrate good. Here I've integrated good. Here is an integral good. Here is an integral. This is an integral. Here is not an integral. I'm only rewriting the function. Okay, good. So when I rewrite this function, I'm going to have, because the k is a constant, I'm going to have k f of x dx. Because the k is a constant, I can take out the k. Because k is common, I can take it out. So once I take out the k, I'm going to put the k in front of the integration sign. In front of the integration sign. Now, when I have it in front of the integration sign, what I'm going to be doing is just to integrate the function now. Integrating f of x. When I get my answer there, so now I just multiply it by the constant. You will see how this pans out. Similarly, it says if I'm integrating a product or a difference, the integral of a sum or difference of 2 or more functions equals to the sum of difference of their integrals. So I don't know what that means. Okay, look at what it means. Me integrating f of x plus g of x is going to be f of x of dx plus the integral of g of x dx. Or if I'm integrating f of x dx minus g of x dx, it's just going to be the f of x dx minus f of x gx. What I'm saying to you, if I'm doing a product, just like a chain rule in differentiation, when it is that you're differentiating individual stuff, for integration, when I have a product, I can integrate them. When I have things grouped by addition and subtraction, I can integrate them individually. So in the chain rule, not a product, in the chain rule for differentiation, just like in the chain rule for differentiation, you are differentiating individual terms. In integration, it's not a chain rule for integration, but for integration, but once I have my stuff separated by addition and subtraction signs, I can integrate them individually. If they are subtracted by division sign or multiplication sign, it takes a different methodology. But once it is an addition sign or multiplication sign, I can go ahead and do my individual integration. All right. And then similarly, rule 8 is very similar to rule 6, right? Rule 6 talks about if I'm integrating a constant of a function, I take out the constant and just integrate the function, d of x. This one says, if I'm integrating -1 of f of x dx, my -1 is considered a constant. I'm taking out the constant here, and then I'm differentiating rubbishness. I'm integrating my f of x dx. And that's what the function, that's what it talks about. That's it. There's nothing more to it than that. I promise you. Let us go through Rockstone. All right, I'm gonna beg you for 9 minutes. It's not 12 o'clock. I'm gonna beg you for 9 minutes. Let us go through the integral of 1 over x squared dx. The integral of 1 over x squared dx, I'm going to rearrange this function to write it as the integral of x to the minus 2. Oh, sir, we're going to use the ln function here? No, absolutely not. The ln function is only used when x is raised to the negative 1. You have to etch that somewhere into your head space, right upon your forehead. Press Ctrl S so that you can save the information. All right? The only time you're going to be using the ln function when you're integrating is when the function itself in the question is written to the minus 1. If it is written to any other function, it is not the ln function. So watch this. When I rearrange this 1 over x squared, I'm going to get x to the minus 2. And of course, this is done based on indices, the properties of indices that you would have previously learned. All right? So this is going to be x to the minus 2. It's not going to be the natural logarithm function. The natural logarithm function only works when you have x to the minus 1. If you don't have x to the minus 1, you are not going to end up with the natural logarithm function. It has to be x to the minus 1. Has to be x to the minus 1. All right? Now, remember now, so now that we've rearranged it, I'm going to get x to the minus 1. Here's my story. The story says, I'm adding 1 to the power, and I'm dividing by the new power. I'm adding 1 to the power, dividing by the new power. I'm adding 1 to the power, dividing by the new power. Let us go to this law number 3. See here? X to the n dx, and I'm integrating. I'm adding 1 to the power, becomes x to the n plus 1, dividing by the new power over x over n plus 1. All right? So I'm adding 1 to the power, and I'm dividing by the new power. So when I add 1 to negative 2, I'm going to get negative 1. When I add 1 to negative 2, I'm going to get negative 1. So my power becomes x to the negative 1, and I'm divided by the new power, minus 1 plus c. Remember, when I integrate an indefinite function, I must have my constant of integration. If you don't have your plus c, is you driving without your seatbelt, you're liable to be prosecuted. You driving without a license, you're liable to be prosecuted. All right? So this negative 1 divided by negative 1 now makes the whole fraction becomes negative. So it becomes negative x to the minus 1. Right? Now, negative x to the minus 1. Let me just put an extra line right here. So copy. Okay. And let me just remove this. Okay. I want to just move across a point. That's why I'm doing all of what I'm doing here. Bam, 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 bam. All right, watch me. So remember, we add 1 to the power divided by the new power. When we add 1 to negative 2, we get negative 1, and negative 1, and negative 1 divided by negative 1 is going to be and negative 1 divided by and all of up here divided by negative 1 is going to make all the function here negative. Now hear me, we never normally write our final answer with a negative power. You never normally write your final answer with a negative power, so we're going to convert it. So that's why I have negative 1 over x. So I'm reciprocating here to give me this as my final answer. All right, so it is really not difficult. Just remember, which is why I highlighted rule number 3, because one of the things that you must remember is that you're adding 1 to the power and you're dividing by the new power. You're adding 1 to the power and you're dividing by the new power. You're adding 1 to the power, you're dividing by the new power. That is your integration. Differentiation, you are subtracting 1 from the power. You're using the power to multiply as a coefficient, and you subtract 1 from the power. For integration, you're adding 1 to the power, dividing by the new power. Adding 1 to the power, dividing by the new power. And similarly, so this is this piece here now, the second question relates to this piece I was telling you about. You have something that is being added or subtracted. You're going to integrate individual terms, right? So that's an example of question 7. So look at what is happening. And let me just show you exactly what it is that we are doing. Here. Oh, I know what I was in. Oh, I can't find the stuff. Dx minus copy is 2x to the fourth plus x 7x minus x 2. All right, so so this is what I'm saying to you now. So you're given, and I'll do this in 2 minutes and end. So you have the integral of all of this here, the integral of all of that. What I'm doing, I'm integrating this first piece, which is what the law number 7 talks about, the integral of the sum or difference of 2 or more functions equals the sum of difference of their integrals. So what I'm doing here, number 2, I'm integrating 3x cubed minus the integral of 2x to the 4th. Because remember, no, this one, if I put minus 2x to the 4th here, look at this one. If I put minus, you know what, copy. Let me just bring across the point with the rules. I never thought about that when I was doing the document. So let me just do it. All right. Plus the integral of negative 2x to the 4th here, negative 2x to the 4th, plus the integral of 7x, plus the integral of 7x, plus the integral of negative 2, plus the integral of negative 2. Watch me. The law, the last one says the integral of a negative of a function equals the negative of the integral of the function. So it means I can just take out the negative sign and put it in front and just integrate the function. See it right here, so? I take in the negative sign in front of that, put it out a door, and just integrate the function. And take the negative sign, put it out a door, see it right here, so, and integrate the function. So what I had for in this question was just that, and then jump to the answer here. But really what I did was 1 law, 2 laws. Teacher, law number 7, I utilize law number 7, and I utilize law number 8 in order to get that done up. Law number 7 and law number 8. As a matter of fact, I can now utilize law number 6 to say that the integral of a constant times a function is just equal to the constant times the antiderivative or the integral of the function. So right here, so I can copy this right here, so I can take out my 3 because that's a constant and put there. I can take out my 2 because that's a constant. I can take out my 7, it's a constant, and I can take out that. All right, and I can take out that. All right, so the law that says, and you know what I should do? I should put it individually, you know. C law number 7, C rule 7, C RULE, C rule 7, copy, C rule 8. So that you can see what it is that I'm talking about. And C rule 6 for this one, when I take out the constant. This one is going to be C rule 6 case. C rule 6. So what's the point? Similar to what it is that we have been doing. When I do a question, a differentiation, I can use all 3 of the rules. When I'm doing an integration, see I've gone 3 rules here already, and there's a third rule in it. So look at this now, the integral. You notice I don't have 1 dx right here, I just have the integral of dx. There's a rule that says we don't write 1 dx. So the integral of 1, written simply as dx and not 1 dx, is this. So this piece here now is going to be rule number 2. And rule number 2. All right. And rule number 2. So I'm using 4 rules in order to do this. And finally, this 3 is this 3 here. And when I integrate, I'm going to put this in blue. I'm going to put this in blue because that's not my final answer. Right. So this 3 is this 3. And then I'm integrating x to the 3rd power. So remember now, I'm using rule number 3 now. When I'm integrating x to the 3rd, I'm adding 1 to the power divided by the new power. So this is going to be rule number 3. So you see how many rules we're going through with one question? 40. We're using rule number 3 case. See rule number 3. 1, 2, 3, 4, 5 out of the possible 8 rules we're using for this one. All right, let's go. So this 3 is this 3, and x to the 3rd is going to be x to the 4th over 4. Why, sir? I'm adding 1 to the power. I'm adding 1 to 3 to give me 4, and then divided by the 4. This -2 is this -2 in front of the stuff, and I'm integrating now x to the 4th. When you integrate x to the 4th, you add 1 to the power divided by the new power. So 4 plus 1 is 5, so it's going to be x to the 5th divided by 5. See here? X to the 5th over 5. And then this 7 is this 7 here. And there's a magical 1 up top. And integrating, I'm adding 1 to the power divided by the new power. So 1 plus 1 is 2. So this becomes x squared over 2. See here? X squared over 2. This one here says the integral of 1 dx is just going to be x. So it's just this x that is right here. So times, of course, is -2. So I get -2x. And because it's a definite integral, I have to put my plus c. So all of this now becomes 3x to the 4th over 4, 3x to the 4th over 4, -2x to the 5th over 5, -2x to the 5th over 5. 7 times x squared is going to be 7x squared over 2. And then this is -2 plus that. And that will be the answer. I know this is a lot. Take a break. As soon as I get the recording, I'll send this off. Please to subscribe to the channel so that as soon as I add a new video to the thing, you can see what it is. I would label your videos accordingly, so it is that you know which video it is. The other ones in the previous semesters are not labeled, so it's difficult to find those stuff, but as you go along, you improve on what it is that you're doing. So I will label the ones that says Calculus 2 Summer 2021. So as soon as I get the recording, I'll upload it and then send out the document as we go along. So have a good one. Go and get some rest and then do some revision after.
Yes.
Best of, take care. Thanks for coming out. Yeah, man. Cool.
Bye.